Missing persons have been pouring in from across the nation, leaving authorities scrambling for answers. The leading theory from specialists right now is that these were not abductions. Rather, these people ceased to exist on the spot. As you can see, CCTV footage captured in Orange County shows a man vanishing into thin air after a series of bizarre movements. Online sleuths are likening it to a phenomenon from video games where players can glitch their way out of bounds. Investigators are looking into all possibilities, even no clipping out of reality.
You know how your parents tell you that everything's gonna be fine and you think you're lying just to make you feel better? Everything's gonna be fine is what Enek probably would say to me right now, because judging from that last stream, where at least the last hour was a bit of a catastrophe, yeah, it can only go downhill from there. Enek, by the way, is running for cover already. There you go. Well, that's actually a bit dark. Let's see if we can fix that later. And yeah, we in the meantime are going to continue our build of our Voron 0.2, not 2.0, 0.2. Where we last time finished cubing it, added some belts and did a couple other things that make it look like more like a printer. At the same time, I kind of managed to screw a few things up, so we'll have to get in there and correct a few things. But before we get started on that, yes, I know who did my hair. I am not planning on suing anybody because I did that myself. It's just something I do from time to time. So yes, that happened. Also, the streaming schedule: 7 p.m. Central Europe, 6 p.m. UK. You may have noticed it's right around that time. 1 p.m. East Coast, 9 a.m. West Coast. If anybody can't make that, if like you have an idea of a better time for this stream, if you have an opinion at all, let me know, because otherwise we're gonna be keeping it here around this time, because this is the time that basically best suits me. Yeah. Otherwise, I did a couple other changes that you can look out for, that I'd be curious to know if those are better from your point of view. First of all, I changed the angle on the details cam so it is a bit closer to me, which means I can use it more often for stuff I need a bit more control of, for. I actually managed to randomize and loop the music, so this was one thing that went badly last time. The last hour you basically didn't have any music, which was kind of unfortunate and shouldn't happen again. Let me know what you think about the music in general. I'd be very curious to hear your opinion here. So yeah, just drop it in the comments. And while you're down there, give us a like. Make that red button gray. Click the bell notification on the side of it, and yeah, let us know how we're doing. I also changed the chat background. You likely cannot see that at the moment because the chat, as far as I know, is hidden until we have a guest. We have a guest. So I guess, hi Omar. Nice of you to join. Yeah. So I guess I need to enable that chat now. Damn. Cool. Let me see if I can do that. So I can actually see it. what's going on there as well. There we go. Now people can write things. Yeah, and obviously, if you're here, drop us a line. Yeah. Also, I was told that I have been a bit too shorthand with explanations and things like that. So let me know if you need any details on topics. I will try to oblige, although not sure how good I am with that. And let me maybe open the chat in a window where I can better see your question and read your question as well. That might help. What else? Oh yeah, and I managed to fix the white balance. If you still notice something, let me know. Let me know. I'm trying to make this look as good as possible, although we will be switching to 4K, or rather 1440p next stream. I ordered a camera for that, and that did not arrive just yet. It will be interesting to see though. It will definitely be interesting to see what a good 4K camera can produce in additional clarity, especially with the manual, because I expect that manual to remain sharper when I scale it down. So you actually get more screen space. And I'm kind of guessing that might be a good thing. Not sure. We'll see. We'll make it work. Yeah, but on to the build. So last time, this is where we were. We managed to again build the frame, build the axes, and build a toolhead. And then I got a bit overzealous and screwed up the belting. So if you look, let me show you this maybe on the overhead here, and there we go. Then I got overzealous and managed to not take this pulley into account, which means that these belts are now too short, and I already cut them to size, so they need to go. That's one thing. Also, we have a problem with the carriage here, because one of the two screws rotated on me while I was screwing that in. So while I made this print head fit somewhat, we'll have to deal with that screw. Well, it's just something I'm kind of curious to see how I can make that work, because I don't think I have square nuts that will fit that, or that are M3. So, and that would be my go-to solution here. Not sure. It's actually something I forgot about last time, so I forgot to order them as well. I don't know. And finally, remember last time we stripped a screw? This one here, which is why it's not populated. Well, actually we didn't strip it, we sheared it off cleanly, or I did, and I was kind of complaining about it, asking what Fysetc was thinking, giving me shit hardware, but this may have been my own doing. So yeah, we'll just have to see. Now, and Omar says the music is a bit distracting. Let me see if I can find something. So do you think I should make it more quiet, or do you think I should maybe choose something else? I guess something else would be nice, right? Let me see if we can find something. Let me see here. That should do. And I will turn down the music just a hair. There you go. Okay. Okay. Let's see how that does. Otherwise, what else? No, this is actually, I think this is actually already it. The only thing I did off screen is install some belts, install some skirts, and the rubber baby buggy bumper feet. So those needed to go on, basically because I needed to put the printer somewhere, and the motor was kind of getting in the way, and it needed some sides that I could balance it on. But yeah, that's all that happened. Today we're likely going to finish the printhead, get into some electronics, talk about a few topics along the way. So yeah, let's see what goes on. But first things first, let's rip off that tool head and let's fix those belts. And that is, I think, 2. This side, I think, is the one that is rotating. If you remember, last time we dropped our nuts into the carriage connector, and I think one of those nuts is rotating on us, which kind of sucks. We're gonna have to take these 2 out, as well as the one on the back, I think. That's this one. And then we should be able to take our tool head off. Bit of yoga here. Printer yoga. Good thing this is a small printer, and that's our tool head off with the nice little cat ears. Those had to be there. Those had to be there. I actually went and remixed the whole bit body just to have those, in case you haven't watched the previous streams. Now taking off the carriage piece here, and this will actually unlock our belts. So we can remove those and rebelt the thing properly. There we go. That should do it from the front. And these are M2s. Oh no, should be the same one, right? No, M2.5 should be the same one. We need this one. We need the magic shearing screwdriver that managed to kill the socket head on the rail carriage as well. So yeah, there we go. Those are coming out. Yeah, and since we're talking about amendments, last time we also talked about the Nighthawk and about USB-BT being the likely best choice for printer powering in the future, in my opinion. And I stated that there's a possibility of having 60 volts running to your bed or controller. That was obviously before I checked the USB PD specs for the, I guess, new-ish 240 watts mode. And yeah, that actually does not use 60 volt. It is still 48. Was kind of surprised, a bit disappointed, because 60 volt would have resulted in a few extra use cases. They may still go there, but potentially even not, because 60 volt is kind of not safe anymore, or at least is the borderline unsafe voltage. So I think they actually stuck to 48 just because of that. Yeah. I mean, it's fine. They had to go with 5 amps instead to make that specific standard work, which in turn meant that they had to go to AWG14, I think, wire gauge to allow for sufficient current, which is okay, I guess. It gives us a bit of headroom, because that means that we can also still make, I think, 6 amps work ish. I'd have to check the tables, but yeah, you could of course use a boost converter to still run things on 60 volts, but I'm not sure why you would. The only thing I can imagine on a printer running on 60 volts are your TMC 5160s. And I think those are fine at 48. Yeah, in case you're interested to know why 60 volts is the absolute border to unsafe voltages, there's a bit of math behind that. We'd have to go into 120-ish milliamps if you use that formula, which means that you are actually in the danger zone, because this is actually quite interesting and slightly funny. Well, actually no, it's not funny at all, because please do not screw around with electricity. It will likely not be healthy. But the interesting part about it is that the danger zone for humans is actually not 60 volts and up, but the danger zone is actually 100 to 200 milliamps, because as far as I remember, if you just get about 100 milliamps to 200 milliamps, your heart muscles tend to just cramp again until they are fatigued and broken. If you get more than 200 milliamps, they actually completely lock up, so you have a better chance of survival if you get more. Interestingly enough, though, countries all over the world have chosen voltage ranges for their main supply that are right in that range where your body could potentially receive a continued, or your heart muscle could potentially receive a continued shock instead of one and just locking up. In either case, though, if you ever get a shock, no matter whether you're over the 220 volts or you think you're over the milliamperes range, please see a doctor. I do not want to be responsible for you not seeing one because you think you're okay, because you got zapped hard enough, and yeah, then you die, which is still a possibility, right? It's just your chances of survival increase the harder you get zapped from 200 milliamps up to probably a point where your organs boil. But yeah, happy thoughts. That got grim really fast. Anyways, that's probably why the USB standard stuck to 48 volts. Slight discourse here. And while I'm talking, I can't get those teeth on these belts to line up. What the hell? The idea being that I just run along here and mesh them until we arrive at the other end. But for some reason, I'm always jumping just one tooth. And these, by the way, are new Gates LGT tools, so should be good. The old ones were as well. Not sure what I'm going to use those for because they're really short, but there may just be an opportunity at some point to build something. Yeah. Yeah, that was a bit of a discourse. Let me know if you want to talk more about electricity. Because I do have quite a few analogies with angry pixies that we can talk about. Although I guess that might end in a similarly grim fashion, which we can get into as soon as I remove a tooth from this belt, because I think I cut that one tooth short, and that is causing my confusion. There we go. Now I need to find out which one's too short again. Damn it. I'm kind of slow today, so sorry about that. The lower one is further in, so let's just go through here. Yeah, exactly. Actually, must be 2. Because, again, since I explained this last time, these should be the same length. It gives us a bit of a good base for making sure they are tensioned the same amount. And now that we have them, that way we can actually go and belt up the printer again. Starting at the B motor, I guess. And we can actually rotate that motor slightly, so it draws in our belt and spits it out the other end. I hope. We'll see. Yeah, it's not. Damn it. This is probably the most difficult part of belting your printer. Getting that to catch properly and move around that motor pulley once. Everything else is just drawing it around. Oh, and I see a belt coming. There we go. I think. Well, we'll need to see. Yeah. Anyways, this whole USB PD thing, I still think it's the future. I hope manufacturers jump on it, get their feet wet with it, because it's the reason why I think it's so important is because at the moment we don't have certified electronics at all in printers, right? We have an open power supply, we have an open plug. You basically need to certify or have your printer certified by an electrician for it to be properly safe and not cause you any headaches. Should you ever need to rely on your insurance, and that kind of sucks. If we had a USB PD power supply that just had a hub on the other hand and could power all the devices in our printer, we could at least reduce the risk immensely by having that part certified and enclosed, and then just integrate that into the printer, even with extensions to the actual device. so it doesn't even need to sit in the skirt or anywhere. So yeah, I think that that might help. And I really can't get this belt through now. Last time this was so easy. Well, I guess it was also wrong, but it was so easy. Damn you. I should have done this once the motors are connected. That way I could just power the motors and thereby screw up the belt. So probably a bad idea too. Let's maybe loosen them a bit. And push that belt in. And grab some tweezers. Where did I put those? Almost thought I lost my tweezers. So that's actually sitting in there pretty well. And now I can use the tweezers to push the belt against the pulley. Let me see if I can show you this. Like I have the pulley here, the belt, and now if I push the belt against the pulley with the tweezers, I should be able to draw in the belt better. Well, I don't know. Like I said, on so many other occasions, I am a software engineer. So, and by the way, I also avoided things like building stuff, even putting nails in the wall for the better part of my life. So if you expect any of the grand wisdoms that people usually have when they build devices like this, you're wrong here. I am kind of experiencing this for the, well, not exactly the first time, because it's not my first device that I'm building, but at least I'm still very early in my understanding of how things should be done. Case in point with the M2 screws that stripped on me. Like I said, I would have expected those to at least withstand a two-finger tighten, but apparently not. Wow, this was so much easier last time. So much easier. That belt just doesn't want to go into there. Well, it's up to the belt. I guess we're done here. Obviously not. No. But I'm not sure why it's resisting. Might get caught on something there. And it still doesn't want to come through. And Enek is getting nervous. He's jumping around here because he notices that I'm getting a bit frustrated. But you know, that's how it is. You cannot always just give up because you're a little frustrated. I know it's a like cancel and quitting culture nowadays, but if you do it like that, you're not gonna finish something. Just stick with it. That's how I got my first device built and found the interest in it. And by the way, I think we got it. Let me get in there to grab the other side of that belt. Not quite. We can actually push it in some more. Yeah, no, Omar, I don't think I found a bug. I think I found a shortcoming on my end, if anything. The bug was removed by removing the belt. That went in too easy, I guess. But this here is likely completely on me. But that damn belt doesn't want to get snagged. Yeah, like I said, the last time this was way easier. Probably partly at least due to the fact that we did it wrong. Well, I did it wrong. Damn it. I need some light in there. And I think that belt is actually getting stuck somewhere. And then just bunching up. So even if I rotated it in, it rotates back out. Yeah, it jumps. Damn you, frickin' belt. Yeah, I guess this is not exactly the start I was hoping for. But it is what it is. We need a belt in there. I'm wondering if I can actually make this a bit easier by just loosening these. Well, they are actually pretty loose already. Yeah, and that belt is just skipping. Damn it. Sorry, Omar. This is probably not the most interesting thing that you imagined. I guess I'm just gonna see if I can find a quick win on the other side. Maybe that works better. Maybe I'm getting some insight here as well. And then we're gonna come back to the first one. The important thing here being that we use this pulley this time. And that we test our carriage first before actually cutting our belt. So we don't need to order another one. And by the way, in case you're ever wondering if I think I did that right with avoiding construction of things and making things other than software, yeah, I kind of regret that. Because, I mean, you see it right now, right? Somebody who actually had experience with building things might be faster in this stuff than me and more efficient. Actually, let me see here. Act of desperation. Oh no, that was too easy. Okay, okay, okay. Cool. I didn't think we had the space there. I was kind of worried that I damaged something, but that seems to work. So the trick actually being that, let me show you this here. And let me see if you can actually see that. I can actually take this belt and run it up. And I still have enough space if I loosen the screws and extend this to just run a loop and then press that loop down. Nice. Nice with sound effects. There we go. And that runs cleanly. Nice. So that needs to go there and around, and then using the pulley here, which means we need to run it down here. I can then just push it in. Belt path, yes. Yes, belt path. And on the other side, we got that out of there. There. We run it around the back. And then instead of running it all the way to the front, we run the upper belt around this corner here directly. And that's our first belt path. That's smooth. That doesn't feel quite right. Needs to be all the way up. Yeah. I think we can make that work. It's kind of long though. Could have probably gotten away with ordering one less meter of belt. Interesting. Yeah, so second belt, obviously the other direction, so it now needs to go straight through on this side. But on the other side needs to take the long way around by going around the front, and then the lower one gonna come out there first. And from here we can push it through. There we go, belts. Now the other thing I last time forgot to do is actually tighten these a bit. Not fully, but just a tiny bit. To give me movement range either way. I don't just want to be able to tighten these. I also want to be able to loosen these a bit if I pull my belts too tight when closing the loop, which we're gonna do right now with the trick we found last time. So we're just going to take both of these ends, make them roughly the same length, then both of these ends, which should now also be roughly the same length. Gonna push those back to back. And our carriage needs to go in this way. So we push them in this way. Yeah, I should have realized that I could actually just run the belts around those pulleys without fiddling with that earlier. That was kind of stupid. And a complete waste of time. But hey, we are learning. I'm learning at least. Now the main challenge here with getting those belts through is to also not tangle them, because if we tangle them we're going to take it apart again. And these belts are majorly resisting me here. And that is not nice, dear belts. There we go. Let's see where we're at. Let's see how badly we screwed that up. Right, and we will need to try to keep these as much the same length as possible, because it really makes it easier for us to then make sure they have the same tension, which for Core XY systems seems to be important, to the point where we're likely going to measure belt frequency later. That's going to be fun. So, but first we're going to check our work here. It's moving freely. You can see the belt path with the B motor going through the pulley to the back, round the back, round the bearing on the other side, around the bearing stack, back to the carriage, and the A motor, which is the lower one, going direct, going outside, going round the pulley, round the pulley, round the bearing, around the bearing, around the pulley, another bearing, round the idler, to the carriage. That looks better than what we had before. Looks way better than we had before. There's still some play in the whole system. So the next thing to do is going to be, I think I want to cut off at least a significant amount of belt here, because it is otherwise going to be a royal pain to make sure they are equal. So what I am going to do is I'm going to take my cutters, snip off one, and then use that as a template to cut off the others. That was kind of nice from Fysetc, I think, because they actually had the belt in exactly the right length. Let's check that. Let's see if we did that well. Yeah, the piece that we cut off is slightly shorter now. So we're gonna remove that as well. There we go. And then we are going to do this for the others as well. So we get a bit of a shorter belt path here. There we go. And the last one. I'm actually making sure that the template is always the one that is a bit longer. That is sticking out a bit. So I have something. So it's not in the way basically when I'm trying to cut the other belt. And to be honest, I don't think it really matters whether we have exactly the same amount of teeth here on all belts. We're gonna frequency tune them anyways, so that should be fine. But yeah, we got our belts. We can pull them in as much as possible. And what we're trying to do now is we also need to get them the same length to each other. Which should give them the same tension. The same base tension at least. And once we roughly have that, we can properly screw that down. We'll need to get our maker beam nuts behind there. That would have been clever to maybe do that beforehand. Yeah, I think I need to do that from the other side. That'll also give us some indexing on the belt due to the teeth running there. So might just help a bit. Or a lot, depending on who you ask. There we go, at least a few threads got started there. And now we can push and shove to our heart's content. Pull this through one. So these are the same length. There we go. And now we need to get the others to be the same length as well. That looks pretty good, and it is actually reasonably tight. So I think we can work with that. We'll check it in a sec to see how well they actually mesh, but I think that should be it. Can run it all the way to the top, and these are the same length. Yeah, I am very pleased with that. Took long enough, so yeah. Anyways, did I mention that we're gonna go 1440p? I think I did. I actually ordered a Panasonic Lumix G80 because I think that is the cheapest, really good 4K 30 FPS camera you can get at the moment on the Micro Four Thirds ecosystem. So really looking forward to getting that. Really looking forward to seeing what that can do. I ordered that on Thursday, so yesterday I got shipped. Sadly, it didn't arrive today. But yeah, very much looking forward to seeing that arrive. And then we'll then you will need to come to grips with the fact that you will have to see my mug in 4K. It's just the way it is. Nice. Now we can tighten these. And the way I would tighten these is actually screw them all the way in. I know that is going to put some strain on the belts. The reason being that all the way in is the only reference we have. And then I would try to back them out in equal parts. So I mean, this is not going to be the be-all end-all of tunings, but we can actually pre-tune this now. So the way we're going to do this is we're going to take our 15 centimeter long ruler. We're going to put that on the center of the pulley. We are going to notice that that is exactly 15 centimeters. Well, no, actually, yeah, pretty much 15 centimeters from the other one, from the other pulley. And now we're screwed because I just noticed I am filming with the phone I actually designated for this. So we're gonna make a few experiments. We're at 15 and we now need to measure the frequency those belts resonate at. So I'm going to use the Sound Spectrum app. And we need to start recording here. And we actually want to measure the inside pulley here. So hold it up against it. And that is way too high. So we're gonna back this out, quarter turn. And quarter turn. And that is still too little, so we're gonna back it out another 1/8. And we can screw it in some more. There we go. Actually need to back this out a bit. And in. And the reason why I'm trying to do this as equally as possible is because the belt lengths influence each other. And if you tighten one, the other will tighten as well. So they're always tightened differentially. Yeah, those are actually pretty close to equal now. I don't actually need the meter for that anymore. Let's hope the camera recovers now though, because obviously I want you to still be able to see what I'm doing from the side at some point. There you go. Yeah, so we already covered the first, I'd say, landmine of topics. Me not reading the specs of USB PD before I opened my mouth. Let's maybe continue with something I haven't had a lot of experience on, because yeah, filtration. We talked about it last time. I know that it is, some people take it very seriously, some people don't. Last time I told you to always be on the safe side, always try to use filtration when you're 3D printing. The way, by the way, I approach this is I think of 3D printing and the dangers of 3D printing being known and us being able to gauge the danger we're actually in. Kind of the same way as with smoking about 100 years ago. So just because it seems to be safe doesn't mean it is. And I would very much want to, while having this discussion, differentiate between 3D printing and plastic safety in general, and the safety of workers in, like, for example, mold production facilities. Because plastic itself, I mean, what the hell would we do without it? We would by far not be as far as a civilization. And by the way, this looks good. I can actually move this, and the printhead mount stays in place. Triple checking the belts that runs through there. So yeah, plastics themselves are pretty safe, because as soon as you're finished working them, as soon as you're finished producing pieces, all the plastic particles are bound, and then they get cleaned off if there's any residue. So that should be safe. I'm pretty sure it is. It's a different thing while you're producing it, while the stuff is in a molten state. And by the way, there's some plastics that release more material while you're using them, some less. Right? I mean, there's a reason why I am drinking from a glass bottle, not a plastic one, because I think there has been enough research already stating that those plastic bottles may not be as emissions-free, as safe as previously thought. But in general, especially plastics like ABS, ASA, nylon, which are the most used plastics, I think. Those should be really safe. Even PET should be good. No worries there. Now in manufacturing locations, in like mold shops, yeah, they're workers, yeah, they're not wearing any kind of protection. Yes, they get their they work directly with the plastics, but I do want to remove those from the equation and the discussion, because I think they shouldn't be considered. The reason being that those production locations, those factories, they are actually, by the way, let me, yeah, that's actually too small. Let me see if I can make that a bit bigger. By the way, one advantage of us going 4K is that I can make this this bigger or this smaller, and it still stays sharp. It's kind of an issue at the moment. Yeah, anyways, I think the factories are designed by engineers, and one of the most important, most critical parts of engineering those will be to have a clean air path. Meaning that even if you dump out a whole large piece that is still hot, that is still emitting some kind of residue, that'll still, that air that contains that residue now will still get filtered, will still get cleaned before the worker is in danger in any significant way, just because the engineers who built those factories, who built those locations, will have made sure, and they were probably mandated to make sure that is safe by the or via their contract. So they shouldn't be any kind of consideration, I think. Then let me know in the comments what you think, and if you're down there, subscribe please. I need some magnification to look at something real quick here, because I think the problem with our screw not biting is that there's no screw in there. that was easy. I may have forgot that. By the way, that is one important lesson I took away from last time. No streams over 8 hours. The mic will cut out around that time. The audio stopped around that time, and most importantly, I stopped functioning around that time, which, by the way, I'm still not, I think, because these are the wrong screws, the wrong nuts. Oh, that's nuts. So yeah, that last hour was very detrimental to this build. I still think we have a solid printer, but I should really not have continued. Anyways, continuing on. The reason why I think the engineers building those places are considering the safety of the workers is because it is freaking expensive for a company if it has to pay cancer bills or doctor's bills for cancer treatments. I don't think any company would want that, and because nobody would want that, they'll make sure that those factories are built in a way where filtration is up to standards. Hey, Jamie. Yeah, so the build is going. I fixed the belt path. That was something I screwed up last time. I just fixed the head mount. Everything else besides one stripped screw, I'm not sure if you can see that there, it's actually not populated, is fine and is solid, and we're just about to get going with the next part. Already had a bit of a grim discussion about electricity earlier. I think Omar actually ran for his life. No, I don't think so. But yeah, continuing with, I think, either the bed, the heated bed mount, or the cabling is probably next. We already did this part. That's actually what we finished on, so you can see things are moving. They are moving well now. No issues whatsoever anymore. And yeah, now it is time. Oh, we already frequency tensioned those those as well. Oh, you were still here? Why the hell didn't I see you in the participants view? Now you're back again. Nice. I didn't know that. It looks like if you don't talk to me, I don't see that you're still there. But yeah, glad you're around. Yeah. Anyways, we already did the 100 Hertz tensioning here. Already did that, so I guess we're on to the print bed. Print bed, we need the 3 screws. Let's move that there. These 3. And we need our actual bed. Our actual print surface. Where did I put that? Oh, scatterbrain, oh, scatterbrain. Where did I leave you? Where did I leave my print bed? That is insane. I just had that thing in hand. Oh, yeah, I got it. I got it. So, if you saw the stream last time, or if you remember, we already mounted the heater. We glued that against here first, so we had a good surface to still have the bed sitting, and then we glued the magnet on the other end, or the other side. So now if we have our build surface, we could put it there. That goes here. That's the next step we're seeing there. What we need to do though is we need to clean up those holes so we can actually get to the screws, which means that the next step will be us just poking a slight hole through here. So we see, let me show you this a bit closer now that the close-up cam is here. Oop. And my desk is too small. Like we poke the screwdriver through here, so we get a slight deformation on the top. Going to do this for the central middle one as well. Oops. And try not to stab myself. That would be nice. I promised carnage, so at some point I will probably stab myself. Do this here as well. Now we know where our screw holes are, and these we will now cut open slightly larger and use our reaming tool, then our deburring tool, to then clean up those holes. The Fysetc build instructions actually say to only apply the magnet once the heated bed is completely mounted. That's probably one way to go, but I like to have these screws accessible. And by the way, by using the deburring tool, we get reasonably good round holes here. That's kind of nice. So, Jamie, you asked how much time is needed to completely build that printer. People have done it in 10 hours. I am probably going to need at least 20. But that being down to me basically having avoided any kind of build stuff, any kind of not software development for most of my life. And that resulting in me just not having the skill and the speed, I think. Also, kind of taking my time here, making mistakes, talking, so it might be possible to do this in 10 hours, but we're probably going to go around 20, whereby we actually already spent like 3.5 and 6.5 and 9, so might need to get a wiggle on, to quote Doctor Who again. All right, so we got our holes cleaned. They're asking us to mount the thermal fuse. The problem I have with this kit and the thermal fuse is that the fuse is actually located in an absolutely shitty location, in an absolutely shitty spot, because it is going to sit here. And the problem with that is that it's basically going to fuse against this little fiddly part heating up, while the whole rest of the bed could potentially be on a higher temperature already. So I really don't like it. I really don't like it. But what you gonna do? It's an M3x8. And it's supposed to be a button head, so these are flat heads. Button heads were a really big bag. There we go. Yeah, so usually you want your thermal fuse sitting somewhere here, at least. But this again would be too close to the heater, and there's no hole to mount it, so I guess we'll go with how they designed it. But ideally I would prefer a better location. Also, and I think this might be different to the way that Fysetc wants this done, I think we're supposed to use a longer screw here. Because the way that this is designed is that they want the screws to look out the top, and then you have the let me actually, no, let's not take this out, but you can see the bed here has keys that you can then push your bed against. But I think I will just mount the let's look it up. Let's look it up. Why don't we? The way to find this is by obviously using a browser, and then look for the Fysetc v0.2, go to the GitHub. Oh, come on, go to the GitHub. We're gonna use the 0.2.1, and we're going to go to the build video that they have up. I'm trying to avoid these, but in some situations they're actually absolutely necessary. And then we need to find the part of this video that mounts the bed. There we go. You can already see the
3x8BHCS.
There we go. Let's see what they use here.
Lock the fuse 120C with M3X14VHCS.
So that's an M3x14 button head. Let me see what you wrote here. Yeah, you just go have some dinner, have fun. I'll catch you later. And while you do that, I will try to figure out which direction they want the fuse to be mounted in, because that would be cool to see as well. They actually mount this to the outside, so we can go back to our manual here. And while the printer's in the way, screw this in. Yeah, but this is definitely something I would do differently. Now that we know that this is an M3x14, we can actually make a pretty good guess about what the other side's going to be, because the other side obviously doesn't have a thermal fuse. So I guess the other side needs to be an M3x10. To be roughly the same length. That's a 12. There are the 10s. Should really sort those into their own proper containers. Ooh, and Enek just woke up. Hello, Enek. Yeah, M3x10, the other side. It's perfect. Perfect length. If we take our bed, just push that against both. Let it pull down. It's sitting perfectly straight. Perfect. Well, actually, well, that may be the packaging, but it's sitting reasonably well there. Kind of like that. Nice. Although again, this thermal fuse is a mess. That really shouldn't be there. That looks so sketchy. Well, moving on, I guess. The thermal fuse, we're supposed to connect to one of the bed wires. This one. On this side, and then that is connected, and now we can move on to installing our M3x40s with a nut and a washer. M3x40s, those are 30s. Should be these. We need 3. And let's put in the first one. for the hole we made. Get that started. Get that in there. And the last one. These still sit above the magnet. We'll need to see if those draw in by themselves or if we need to do some dirty little tricks to get those to seat properly. Or if we just need to take them out again and do this properly. You know, that might be an option. Anyways, we were talking about safety and filtration. I told you that I think we should take the factories out of the equation because they have a vested interest not to have their people get cancer. So the plastic production may actually be safe by way of good filtration and air paths inside those factories. But at home you should really look out. You should, I mean, it's not just about plastics in general and those being unsafe. I think most plastics should be safe, but I would still avoid them. I would still very much avoid them in if I have a chance. So drink from glass, don't drink from PET bottles as much if you can avoid it. Might also help the environment to some degree. There we go. That actually drew in pretty well. Yeah, and again, the whole engineer designed the air path does not actually apply to you at home. And you at home then need to make sure that you're actually safe, that you're actually not poisoning yourself. For me, this is pretty important because it's not just me here, right? Much more than that, there's also Enek. I'm not sure if Omar watched the previous videos, but need to make sure that QD is safe. And let me see if I can actually make that a bit brighter, because that is abysmal. Let's set that right. Let's put that right. And let's actually put that just by way of going auto exposure. Yeah, there you go. There's the devil incarnate. And he's just waiting for me to finish up this printer so we can go outside, have fun. No tricks right now. Well, we'll maybe do that later. But in the meantime, we still need to add some M3 washers to our construction there, to our bed. There we go. And again, I'm trying to make sure that anything that moves on those washers gets the side that doesn't have the burr, because the way these are made is they get stamped, and that always leaves a slight burr on one side. So I'm trying to avoid having that burr be on the side that actually moves. They're applying the magnet here. I actually avoided that. Don't think it's a good good order. Because again, you want a flat surface, and if you mount the heater first, then you don't have a good surface anymore to balance your bed on. So I try to do the heater first, the magnet first. All right. Now we need our springs, and once we have the springs mounted, we need our screws, because these are meant to then let us adjust the height of our heated bed. I imagine we also need these at some point. Oh. So these are Fysec's thumb nuts. I'm kind of guessing Fysetc wants us to use those in favor of these. Screw that. We're using the yellow ones. We're definitely gonna use the yellow ones. These silvery things, they're just this. But no. I refuse. Would probably be better and more stable to use theirs, because some proper thumb nuts can make this really rigid. But we already lost a bit of an accent color when we used their bed mount here, because otherwise this front part here would have been in yellow. And it's more important for the printer to be bright than to function well. So there you go. Priorities. All right. Thanks for sticking around, Omar. I'll see you soon. There we go. And then we just add these here. And we get to mount our bed. Now, let's see if we can actually do this without losing springs. But I like the springs there better. It's easier to balance the whole thing on the springs instead of the washers. There we go. Cool. We get shown the path for the heater wires. I guess we should use that. Let's see here. It's gonna be slightly difficult to still get those in there. But I guess we can make it. I guess we can make it. I guess we should make that path work first before we put down the bed completely. Yeah, and by the way, this is a clear advantage of bigger printers, is you just have more room to work. Because I will have to take that off again and make sure I put the wires through the channel first. I also don't like the way that the heater is running here, so let me quickly check how they how Fysetc wants to organize these.
And pass it through the hotbed aluminum plates from above.
Because I'm kind of tempted to disconnect our fuse again, run that through the path, and then connect it on the other side. Although that would impact our ability to
With a wrench.
just quick release that as well. So I'm not sure if that's a good idea. We'll see. We're going to see how that works. So we can actually turn the printer over, run those wires. And probably better if I show you this here.
Pad M3 shimmering.
Push these through.
Take out 3 spring and M3 thumb nut.
Kind of tight there. Really tight there, actually. And they actually fit. They fit well. Nice. Now we can just fold our bed over and all the wires are at the bottom. I like that. I like that a lot. Not sure.
Put the hotbed aluminum plate screw in through the spring hole.
Yeah, we're already supposed to add our yellow nuts there. Our yellow thumb nuts. We can still add the thumb nuts that Fysect provided later, but I like to have some color. I'm actually kind of bummed out that I have a Fysect logo on the front now instead of a proper Voron printed part. But that bed is just too damn good, I guess. There we go. To be honest, I think this is a bit close. I think there should have been a washer down under that as well, to make sure those thumb nuts are accessible a bit better. I'm not sure if I like this. I may actually add a like a spacer there. But I guess this is optimization. It's kind of hard to get this started. Probably because this print has a slight elephant's foot still that kind of got increased by the heated insert needing to go in there.
Put a sticker
Me.
on the top.
Oh, let me stop the video here. You're probably still hearing the comments, and I'm trying not to watch these. Trying to work with the Voron manual as much as I can, except for some major differences, but the rest we will figure out. Don't think we will have any problem doing that. The problem we have now though is that our nut is rotating, and that's especially critical because I don't have my wrenches handy. We'll need to make a quick excursus to one of my drawers to get that, and then we can actually tighten this. I think that's the right one. Might not be. Damn. We could potentially have used thread locker on that screw to lock it into that nut, but might not be necessary. In general, if it comes to the bed, I would probably want things to be... Oh no, we do not use thread locker here. That actually doesn't work. That may actually be detrimental to your build, because thread locker usually is not made for higher temperatures. There is some stuff that is made for higher temperatures, but we want our bed at 100 or 110 degrees, so in general I think it would be better to not use any thread locker here, because that may have some adverse effect even. I'm now screwing those in so they don't have any movement anymore, so they actually just touch and keep in place these screw. So there's barely any slack in the system left, but we will still need to adjust this later to get this completely right. If I remember correctly, this shouldn't be necessary all that often though, because especially with this bed mount, the position should be stable. I think I broke something else. Oh no. No, it's just the screw that's rotating on me. And yes, I have considered using wet and wild on these, because haha, getting those screws wet and wild is always fun. But I don't have any idea of how nail polish behaves at these temperatures either. There we go. Bed mounted. Success. Not adding the PI sheet yet because obviously that should stay as clean as possible to make sure we can print on it still. So we're told that there is a channel on the bottom that we can run the wire through. In case of the Fysetc build, that's actually not what we're going to do, because in case of the Fysetc build, and let me maybe see if I can show you this. You remember we have this this Wago wound. What we're going to do first is reconnect the thermal fuse, and this is, let me see if I can make this work. There you go. So I reconnected the thermal fuse, so that's there. We can make sure we can get this cable stored somewhere, away somewhere. The other thing we want to do is we want to connect our two cables here, and there's definitely a shorter and a longer one, so we're going to connect the shorter red one. That's whoops, the shorter red one we're going to connect to the closer one and to the closer Wago mount, and the longer black one we are going to connect to the further to the Wago mount that's further out. And this, to be honest, is kind of cool. I like that. I like that. Well, let me put it this way. I am not a fan of just blindly using Wago mounts everywhere. I don't necessarily am a fan of using Wago mounts here, because if you use a Wago mount here, it kind of implies that you want to quick connect and disconnect your heated bed, which I'm kind of questioning whether that is necessary. The thing I find very nice here, though, is the cleanliness of the wiring that we get now. Because look at this. This is basically it. We can cable tie this together, so we get a bit of a, like this is still going to vibrate. This is potentially even going to vibrate in a way that can influence our input shaper graphs. So definitely gonna tie that down somehow. But this is pretty clean. That's what I like. Obviously, you can get it just as clean or even cleaner if you can take the slack out of the cables here and draw them through the cable chain down to the board. But this is nice. This looks nice. This is cool. The thing we need to do now, though, is we need to route our actual cables, which means we need to find them first. gonna need our cable chain. This is a switch. This is our motor. And this says V1 and G1. These are pretty beefy. I don't think because they have these because they have these types of connectors, I don't think those are it. I have some more cables here. Let's check these out. And these say, hey, HB for heated bed. Now the question that pops into my mind is whether these will actually be our heated bed connectors, whether I want them to be, because I am not a fan of these. If I actually have a screw terminal, I want these to be rings. If I don't have a screw terminal, if I have like a pressure terminal, then I want these to be basically these. We can, I guess, still get these routed, but we'll need to clean that up after to make sure we have either rings, which I think they will be, or let me get this here real quick. Either ring terminals or lugs on there to make sure this is safe and proper. But yeah, that means that, and let me put you back here. We need to now do some color matching. Red to red, black to black. Or to put it in angry Pixies. By the way, do you know why Pixies are angry? Why those Pixies are angry? I have a theory. I think it's because depending on whether depending on how you look at it, but I think they're angry because they got their wings stolen. They got their wings cut off, and now somebody put the wings on the other end of the cable. So I think those Pixies are just trying to get their cables back, their wings back. They're obviously trying to do that so they can have a bit of a riot. Guess they like that. Yeah, but that's angry Pixies, because that would explain so much. That would explain why they're running from one end of the cable to the other. It would explain how you can put a funnel in between them and they bunch up. Why the funnel obviously being a resistor, why they collect on one side of the funnel then and they stay angry and you have a lot of wings on the other end, potentially, I'm guessing. And yeah, that's kind of, I guess that's electricity. Just a bunch of Pixies that got their wings stolen. Obviously, electricity itself being about the difference in electrical energy potential. Right, that defines your voltage, and then your current, which is the other interesting metric, is how much power, how much force you have behind that. The question becomes, where is my thermistor wire? Yeah, and those pixies then probably get into your heart muscle and kill you slowly. They have a party to get the loop to the topic we had previously. So do not let those pixies enter your body. You are not going to have a good time, but they will. They will. And I still can't find my freaking cable. I can't believe it. Where is it? I mean, we could just crimp one. We could just crimp one. We have a bit of an excursion into soldering to do still as well. Well, actually, that is one I probably want to do off screen, because we still need to mount our LEDs here in these two places. But especially with the mini stealth burner, that is a freaking pain to do. Especially if you don't want to use two signal pins to control them. Is that the one? Might be. Yeah, that looks good. Yeah, so fun things coming up. And this says B1, no, TB. I guess it's not important how we orient them, because of course a thermistor being measured by its resistance, and its resistance changes with the temperature it is exposed to. And we're down here. Need to route our cabling there. And run the cables through the chain. I had that chain. I had that chain in hand already. Don't need that. Oh yeah, there we go. Directly in front of my nose. Now we need to make sure that we actually get the direction right. which means in this case it's the, not sure if you can see that, the inner ones need to go in the end where the cables enter, and the outer ones need to be where the cables leave. The interesting part here will be whether this stuff actually fits through here, because that's usually the problem with these very small chains and your JST connectors. They probably don't fit. Oh, actually this one does. Barely, but it does. So I guess we need to do these one by one. And just fiddle them through. Because they do have this lip on them. That makes it kind of hard to do, and the further you get into the cable chain, the harder it actually gets. This is, by the way, somewhat analogous to how you control your filament in your nozzle, right? And how filament in the nozzle gets controlled and flow controlled. It's basically by pushing more filament through, and the further away your nozzle is from your extruder, the less precise and the more difficult it gets to push that filament through in a controlled fashion. That, of course, being a case for using direct drive extruders over Bowden extruders. But it also highlights why the whole process is reasonably precise, even if you use a really good extruder. All right, we got those. I would actually like to do some cable management here. But I don't think Fysect accounted for that. There is a hole here that you could run cables through, but then they would run around the carriage here. Let me check their video. Let me check their video. I hate that I have to do this, but let's see how they do it. Because this is reasonably important stuff. So they run the cable through. And let me show you, just so you can see it as well. they don't actually run the cables through the chain, but they are using a cable sleeve to make that work. Okay, okay. Not sure I like that on this distance. I mean, that would mean that we should have a short piece of well, actually we can do that later. We can do that later. We will need to do that later, actually. In the meantime, we can screw our bed a bit up, get that cable chain to move this way, so it goes up here, and lightly click that into place already. I'd actually really like to secure the cables via a proper zip tie here at the start of the cable chain. But I think we will also leave them bare wire for now. Where it would probably be good if we move this up though. And I think we will need use this hole in the CNC mount to just get a zip tie through there and fix those cables in place. Whoa. Let's just get those through the hole here as well, just so they're out of the way already. Yeah, what else do we want to talk about here? Somebody asked me, since I went hard on or I don't actually think I went hard on the Leviathan, because I still the Nighthawk. The hardest thing I went on it was that I got the spelling wrong. Sorry for that, by the way, LDO. But yeah, for me personally, there are a couple other Toolhead boards out there that I like better at the moment, like the Mellow SHT. But somebody asked me about my take on the Leviathan. That one is cool. That one is really, really cool. I like what they did with the cooling for the steppers. I don't think you actually need to concern yourself much with steppers and which steppers you're using. to the point where you want to have the ability to go higher than 24 volts, potentially on the A and B motors. And by the way, struggling a bit with the cable chain here, but I'm not sure that matters much. The board itself looks insanely good. I actually love the color scheme. The manufacturing looks really good. I like that they, well, let me maybe put it this way. Usually, or in general, I think this disconnect between the Clipper controller being a completely separate board from your MCU, and the Clipper controller obviously being your Pi or CB1 or what have you. In our case here, the daughter board on for the Catalyst. Let's use some pliers here, get some leverage. Those boards being separated from the thing they're actually controlling, I find somewhat surprising, not to say tedious, and I do actually like some proper integration. So I would like to see a board that actually has the MCU and everything integrated. Now, with the Leviathan and LDO being a Chinese manufacturer, I can actually appreciate why they didn't. Because there are many questions around potential backdoors and things like that in Chinese hardware and Chinese operating systems, and me actually being able to run a stock Raspberry Pi on that gives me confidence. It really gives me confidence, because I know that the stock Raspberry Pi image will not have any funny business in it. I think that's an important consideration. Same goes for Victory Tech, by the way. Now you're probably going to ask, hey, but in this case, like you're just building a printer with an integrated board. What you're gonna do now, Paul? Yeah, first of all, this particular printer is never ever going to connect to the internet through my network, through my internal network. It just can't. It's just the way it is. It cannot do that. As I said, I'm working as a software developer, and there are a couple concerns here about that potential software image not being clean. No offense, I'm not trying to single you out. I know that Chinese people do great work. I know that without you guys, the rest of the world would probably be back in the Stone Ages. And I do appreciate that you exist, but there are a couple of things that may be sketchy in how you tend to do things. And I think you know that. And I think you appreciate that, you may appreciate that I need to be somewhat careful there when it comes to my professional work. and that being on the same network as my personal printers. Yeah, means there are cautions I need to take. It would probably be the same for me running a bamboo printer here, to be perfectly fair. Right? So it doesn't necessarily have to be a Chinese company that I am weary of, or that I'm careful with. And to be quite frank, I think that Catalyst board should have had a proper CM4 mount. And I wish the Leviathan did too. Because I like the CM4, and I, in many cases, cannot see people actually going having pies around en masse if they build printers, if they like to build printers. And they may, but if they have pies around, they probably also have CM4s around. And I just like the integration of the CM4 better. Personal preference here. That's also why I like the Manta MP5 so much for Trident and Solid Fork builds, and which is why we're going to move there, paired with those boards then, by the way, receiving 2240s, TMC 2240 controllers, because I also like SPI communication better than UART. Personal preference. I just, from an embedded developer's point of view, I cannot appreciate the finer points of UART communication, to put it this way. I like my SPI. So I'm going to go with 2240s on, by the way, this rebuild, once we move it to the Octopus and repurpose it to Dual Link 0, whenever that happens. We're also going to go at Manta MP5 on the other two printers, although the Trident could potentially get a Leviathan as well. The other concern, and by the way, this is not a concern for me, I have with the Leviathan is that it uses TMC 5160s. That's completely appreciated, and I like that they're there for your AB motors, in addition to 4 stepper drivers for your Z-axis at most. But according to law, or the grapevine, or however you want to call it, I hear that TMC 5160s are a pain in the ass to get configured for sensorless. So sensorless homing may be hard to set up there. Not that it concerns me, because I like my sensors. If anything, I would want to go not sensorless, but optical sensors. Not sure when that's happening, because I'm not sure if anybody did that. If anybody did that ever. But by the way, we got our bed cabled. It's still a bit rough and ready, but we're gonna leave it for now. We're gonna sleeve it and make it pretty later. This part we did already though, so we're ahead of our time. What we did not do yet is mount our Toolhead board and connect everything to it. Again, we will need to probably reference the, there we go, here it is. We'll need to reference the Fysetc side. The problem with this toolhead board is that we need to mount our toolhead first, so we can screw in the toolhead board from the back. That, by the way, I think could potentially be improved with another iteration of the mini stealth burner, because I would love to be able to just take off the whole thing. Oh, and we need to move our bed out of the way to be able to properly hit that. Now the question is that nut still in there? Or did we lose our nuts again? Which we tend to do here. The answer comes by way of some magnification. Yeah, that sucker's gone again. It escaped. It escaped. Dropping nuts here left and right. There we go. That was nuts. Now we can mount that. Screw that in, and by the way, no wet and wild here, because obviously we want to be able to take this off whenever we need to maintain our printer. Need to make sure that it's reasonably tight, and then we can screw in the one from the back. That also screws into a preloaded nut before we mount our toolhead board. Now the way Fysetc wants us to mount this is with a top. I'm not sure I like that. I'm not sure I like that, to be honest. It kind of looks cool. Yeah, I guess we will. I guess we will. But first we need to do the remaining cabling. We need to connect ours. Let me see if I can show you this in the close-up. Now that it's a bit closer to me. So it's kind of close up. Let's move the focus a bit out. So we're going to connect this way here. We need to connect our heater wires. That is a flathead. That's probably something we should have done before we connected this one. The heater wires being here. And this is, by the way, why I would love to see this as a thing you can do separately, because now I need to deal with the wiring with the whole printer attached. If this was separate, I could deal with the wiring, just with the wiring. See if we can get some focus in here. And I'm trying to maybe sort my wires a bit. I also just noticed that, of course, I have the G-Design blower fans pre-crimped, but the hot end fan, which is the Sunon, is not. So I guess we need to get our crimp on real quick. And we can likely use the G-Design fan as a reference. I'm quickly going to double check that those are in the same direction that the other fans go. That we put aside. So these, by the way, the El Cheapos that you get with your Fysect kit. And if you look at these, we need to push back the, we can actually zoom out here, but oh no, that's in. Huh. The service, let's maybe turn it this way. We pushed back the wires a bit, and we see that if we turn the key to the bottom, we have the connector pointing away from us. We have the black wire on the right. Now, one thing I noticed just now is that these are a different size, so we'll definitely need to recrimp those as well. So that's kind of a pain. Take this off. This should be fine. And the trick will now be not mixing up our our fan wires. So we're going to crimp those first and then snip off the others. Also, these are not the right connectors. These are too big as well. Damn you, Fysetc. Damn you, Fysetc. Threw me another curveball. I really hope you included these smaller JST connectors for me to crimp myself. Because otherwise, that's where we're stuck. That's where we'll be for today. At least on the hot end. We can still continue on other places. Can probably do the whole wiring. Just leave that way. But yeah, that would still suck. And I see smaller connectors. So they did include this whole baggie here. And if you look here, these are the smaller connectors. We actually get 5, so enough room to screw things up. Just need to get these crimped. Shouldn't be a big deal. Just if anybody's interested, these are El Cheapo crimpers. Zushan. I don't know. I have never used PO9s. I have never used anything else. So I am not sure what's better, what's worse. I know that these, for me, work just fine. Just gonna insert that there. Without it popping out, of course. Then taking a cable, pushing that through, crimp that down, move just a tiny bit forward because we don't want to actually compress the whole connector. We just want to compress an additional piece, and that is on there. Although I don't like how far out that still is, and I don't like how the cable got crimped, so let me maybe get some magnification on that. See what's going on, how we did that. Yeah, I'm going to do that again, and I am going to do that using some magnification here. Probably faster. Never be shy around the tools you need to make things work. People have had fun on me using these during the first video, but they work. Oh, and I am obviously being an idiot here, because if I clip off the end, yeah, that's really rough and ready. But it's gonna work. But I obviously also need to restrip that wire. And by the way, that was the issue with the other wire just now. It was stripped way too long. You need about 2 to 3 millimeters of a strip to make this work. Put that in there. Compress. Move forward, compress. That's a good crimp. That's a good crimp. So that is our fan. You can see those here. These are totally fine. We can basically have a look at the old fans to see how they need to be wired again. Let me see here. Key to the bottom, connector pointing away, red to the left. So key to the bottom, connector pointing away, red to the left, and with the tab to the top. And the tab is usually on the non-extruded side. On the flat side. And then we can use a somewhat unconventional tool. Not even sure what that's called in English, but it's basically the tip of a circle marker to push those in properly, get those seated. Because obviously we don't want them to pull out. Yeah, anyways, we talked about the Leviathan. We talked about what I like, what I don't like. Our connectors in the meantime are seated really well. So we now can snip off the too big, the connector that's too big on this side as well. And then we strip all four. Perfection. Get those a part of it so they're easier to work with. Strip these as well. Get them part of it so they're easy to work with. And then get some more crimp connectors. I guess that's the stream today. This is a crimping stream. I mean, we already had the heat set stream. And Adam with his Neo Rep is actually making that very popular, I'm guessing. Ooh. And now I completely snipped the connector, so we strip that. I just tried to use a smaller opening, and I'm guessing the forces are just too much on that one, so it's a good thing Fysetc included spares. And by the way, I could be doing this completely badly. I have never had anybody instruct me in how wires are supposed to be crimped, especially GST connectors. I just know that this is the way I get them to look kind of like what's coming out of the factory, although this one's really bad. I'm having really bad problems with these small as shit connectors. But I think that's actually my technique rather than this being the fault of the crimping pliers or anything. I actually never had to crimp this size. Yeah, there we go. That's good enough. I think I have an idea why they are behaving this way. They're actually trying to escape. The importance of a clean crimp obviously being a good connection. If you don't have a good connection, you get heat buildup in your connections. That would suck, especially with a fan. In this case, a parts fan. It's kind of important that those produce good quality. And this is fiddly shit. Again, using our circle drawing tool. Just making sure that they're seated properly. And the pull test reveals that while it was seated properly, there was a problem with the crimp connection. Damn it. I will actually move down my desk a bit. Yeah, Fysetc. Why? What was so wrong with JSTSH? Every single fan I know either comes without connector or a JSTSH. Yeah, fine. These are really fiddly. I mean, they're better than the Big Tree Tac SB2230 40, which, by the way, Big Tree Tac, why do I have a 36 watt capable 2240 on my Toolhead if I can't actually use it? for 36 volts. I mean, I do like that it's there because, as I previously hinted, I do like me SPI better than I2C, better than UART. But has anybody ever tried running a 36 volts extruder? Not that it will make much of a difference in extrusion quality, but if I remember correctly, one of the issues with those extruder steppers is that they're running freaking hot. And one of the advantages of using a higher voltage is that it will need to, or it can have a lower current to produce the same power, and the power ultimately being the thing that decides whether your filament moves or not. So I would imagine that, especially on that toolhead where you may want to run your stepper as cool as possible, taking advantage of 36 volts would be cool. I mean, having a 36 volts heater would also be cool, because that would also reduce the size of the wires there. Sure, it's a bit of, I guess, diminishing returns at some point, but there are returns. There are returns, and if I'm putting in a state-of-the-art state-of-the-art 36 volt capable driver on my hot end, or on my toolhead, why not at least give my users the ability of just running the hot end and the hot end heater I think we got it. The hot end heater and the stepper motor at the higher voltage. I mean, wouldn't that be cool? Maybe it wouldn't be practical, but wouldn't that be cool? I really don't get why that's not enabled. I mean, you have voltage regulation there anyways. You're offering 5 and 12 volts for fans, so you could just as well have another regulator to run those I don't know, 2 to 3 fans at 24 volts. That shouldn't make much of a difference. Sure, it's a bit of extra circuitry. Make the board a bit bigger. You have the space. Yeah, why not? I mean, it's a limitation that in case of the 2240, I really don't understand. On the other hand, mellow. Where's my SHT 36 with a 2240? That's 36 watts capable. I will need to look up whether there are even heaters that support that, but I would guess that that's a way to go. The real question now, though, is, oh yeah, where did I put the board? And by the way, we have one more to crimp here. 1, 2, 3, 4. We need to crimp the fifth one, and we need to cut it to size first. These, by the way, being our filament sensor. And if you, so here you go. These are the extra wires we ran for our filament sensor. And if you look on our board, we have 1, 2, 3, 4, 5 connectors. So we have our thermistor, we have our fan 1, 2, 3. And then we have an unpopulated end stop pin. And that end stop pin we're going to repurpose to be our filament sensor, because there just is no end stop. We're going to go sensorless, and because we're going to go sensorless, we don't need a sensor. We can just use our remaining plug for our filament sensor. Here we go. This, by the way, being our last chance for, well, not really, because we can just reclaim those plugs. The only thing that would limit us here would be the pins, and we do still have some of those. What sucks though is the fact that our wire barely fits into those. But we're good. We're good. It's all good. It's all good. Yeah, anyways, toolhead boards. Again, my favorite currently being the Mellow Fly SHT. Not so much because of its architecture. I mean, the Fly SHT is, or Fly SHT 36 is very, very close to the EVP 36. Those two being the only ones we can actually use for most of the builds. The Trident actually has an SP 2240. That being the exception here. But our salad fork and this printer, once we move it to CAN, though, not right now, but once we move it to CAN, will receive a Fly SHT 36. Ooh. There's a Robert. Yeah, Robert. So what's cooking is a good question. The we're currently wiring the toolhead board. I mean, you can see it there. I just crimped the last two last two wires. I hope those connect well. The main question now is, and this is something I actually need to look up, is what the polarity on those would be. So let me move us to the browser real quick. Can actually just go back here and have a quick look at the wiring. No, actually it doesn't tell us here. That sucks. Then we need to go somewhere else. I had a bit of trouble still getting the belts here in place properly, but in general looks good. The only thing I'm kind of worried about is that you can't read chat right now. That sucks, but yeah, thanks for subscribing. Definitely going to get into electronics today and maybe some more crimping. But first let's find the catalyst board. There's the catalyst kit. So we can have a quick look at the polarity here, because while it shouldn't matter, this is the catalyst board itself. That's not actually what we wanted. That's the toolhead board. That's the schematics. Yeah, so we're basically trying to let me show you this. Basically trying to wire all this against this, so we can then use a big connector from this to run it to the actual main board. I am actually going to assume that all of these are wired the same way. So if we look at this connector, for example, it has the ground connection pointing towards me when I plug it in, because they're all keyed in the same direction. So the middle connector is actually the one we want to populate right now with our own connector. So we are going to assume that that's the same thing. And we're going to just wire it up the same. It'll be fine. Yeah, we talked about angry pixies before, so if you want to see something funny, maybe look at the rerun. And I kind of started off with some more grim topics about what kills you in electricity, since I talked about USB power delivery going to 60 volt last time. That was kind of a fun aside. All right, so this is wired now. Pull test looks good. Pull test on these looks fine as well. Cool. So if I remember correctly, and we actually saw it in the other repo, in the wiring diagram, let's use the PDF. The fans, and let me move you back to the manual. No, let me back, you need to be at the browser. The fans are fan 0, fan 1, fan 0 being our parts fans, fan 1 then being the hot end fan. So these having the same cables. Guess we go back to the overhead for this. These having the same cables are our parts fans. Clock. And go in there. And then we have another one, this one, that's fan 1. We have our repurposed filament sensor in the toolhead. And as a last connection, we have our thermistor. And that's our board. That's how that looks. The only thing we still need to connect is our heater. And for that, I need to quickly grab a small flathead. And because they're so small, I need some magnification. Yeah, that'll do. Yeah. We already did our heated bed today. Ooh, this thing's getting heavy. So if you want to see it, like this from a mechanical point of view, there's a printer here. There is a printer here. You can just go click, and you have a printer. As soon as we have this board mounted, we're actually pretty far in. Then it's oh yeah, we did the wiring for this as well. So cable chain going here, some cool connectors underneath there. Did all that already. Kind of satisfied. But yeah, let's continue here. Ooh, this got dark, and I don't mean dark in terms of topic. Yeah, so with the heater, the hot end heater, we don't actually need to look out for anything specific in terms of cables and cable management. We just need to make sure it actually fits. And I'm going to disconnect our stepper here for a moment. Reconnect that once the wiring chaos is out of the way. There we go. That needs to sit like this. And then we need to route our wires in a way where they arrive there. And I see an issue here coming up where I'm not going to like the side I chose to run those wires up, because they seem to be reasonably short. Let's see here. No, I guess we're good. I guess we're good. I can just route these underneath all the other cables. This is hard on stream to make this even visible is kind of hard. But we're gonna make it work. Yeah, the one thing I'm not sure about is what the hell Fysetc was thinking here with those crimp ends, because those will definitely stick out of this terminal block. They do seem to fit, but I am kind of worried that they stick out too far. Oh, and I see one of our crimp connections is trying to escape. Where are you from? Oh, you're from our filament sensor, from our dodgy connection there. I guess you weren't seated properly. Yeah, now he's now it's in there. Pushing those down. Some pull tests. We're gonna verify that that works later when we actually have power here. For now, I am just going to screw this down and manage a bunch of cables, because they can obviously not be sliding against the extrusion. That would be bad. So I'm guessing we can go with some M3x8s. This is kind of a cool view. You can actually see a lot there. Nice. Yeah, and in terms of programming, there is this software called Clipper, so that actually takes care of most of the things for you. There is configuration and configuration management to do, so that's definitely coming up, and you can do Python programming with it. There are a couple of things I would like to do, but I'm not sure we're gonna go anywhere near those during this build. The reason why I'm building this in the first place, and this is actually something we can talk about. The reason why I'm building this in the first place, why I'm building a V0 in the first place, is to have a backup printer. Because if you remember, I already have a printer. That printer is insanely good. And I want to mod that to do different things, to be faster, to suit a few more use cases. To do that, I need a replacement printer to just have something available in case I screw something up. I need to reprint a part, I need to fix a problem. Obviously, if you're working on your one printer is 0 printers. 2 printers is 1 printer. So that's the theory there. Let's lock those down. So yeah, that's the basic idea, is build this. So I can build another printer actually. I do want to build another printer that's supposed to be the actual backup. So wait. So all the way back to the beginning. You remember I have a printer. I also ordered another printer. Yeah, you can control this over Wi-Fi since you asked. It is actually the way it works is you have a program called Clipper that runs on your on a Raspberry Pi. That program then controls the MCU that actually runs your printer. That's a completely separate MCU with a completely separate firmware, and that in turn controls your motors, and you can access or modify behavior of your printer basically via SSH or any other means that you can remote control a Linux system. So that works kind of well. Ooh. Let's not end the stream here. That was a misclick. Fatal misclick. Anyways, the idea of building this is actually I actually wanted to build a different printer. I ordered it pre-Christmas, wanted to build it over Christmas. Didn't get it delivered. So in a fit, I ordered this printer hoping it would arrive sooner than the other one. Now I decided to stream. I need a replacement printer in case I screw something up modding my main printer. So I was thinking of using the other printer I ordered pre-Christmas for that. Then I decided to stream, and the other printer is kind of a specialty item, or more of a specialty item. So I'm using this to calibrate the stream, then show off the other printer build on the stream. Then I actually have 2 backups. Then I can mess with the printer, my main printer, and really deck that out, and then move on to other stuff. There are a couple other topics I want to get into. Like, again, the salad fork printer is a bit of a more specialty item. It's my main printer built with tiny or with smaller components like this printer. Because if you look at this, this is tiny. This is small. This is 12 by 12 centimeters print bed. So yeah, the other one has 15 by 15. Still really small printer. But to be honest, I like them. Small printers are really practical. I mean, look at this. This is that's just about. You really don't need much space for this. The worst thing on this is that it's built with 15-15 extrusions, so these smaller things, because these are a pain in the ass. But otherwise, really like the format, which is why I'm going to build a 15-15 variant of my bigger printer using something like this, or like parts like this. That's gonna be pretty fun. But first I wanted to figure out the streaming thing, so using this printer for that. And then there are so many other topics I want to look into, like recycling. There's a company called ArtMe that has a machine that lets you make your own filament. The only restriction is you need to be able to grind your parts, so you can actually do so. Anyways, we finished wiring our toolhead, so we need to move on in the manual. Then I still have that pick and place machine. I still have the CNC laser combination to build PCBs. And once we have that figured out, I need to rebuild my Panda placer, the pick and place machine, to then be able to properly build PCBs. And the ultimate goal here being, and I'm not sure I showed this on stream before, I want to build my own game console. And until now I had to basically use pre-made parts, these being Adafruit Feather parts. You can see your display. This is an ESP32, so it also has an ESP32 module on the back with Wi-Fi and everything. You got your joystick and stuff, and it's got a battery. It's got a bunch of things in there. The most notable thing here being an orange crab board, which is an FPGA that I want to use for GPUs. I want to build my own GPU, or I actually to some extent have built my own GPU. There's a bit of work there left for the rasterization and stuff, and I want to like build that and give it a nice case, give it a good PCB, give it the components I want to use and not the components that are available, because for example this joystick is nice for testing, but for actual play it's abysmal. It's not a good thing. The way the battery is wired here, the way the connections are wired here, I mean, just look at this. There's like 15 USB-C connections on it. It works as a prototype, but it's not clean. And even for this, I actually want to print a case so I can take it on vacation, so I can take it with me when I'm traveling somewhere. So that's what I need 3D printers for. That's the plan here. And once I got that figured out, then it's on to building the actual console. No, wait. I think I lost my toolhead cabling, but I don't think we need it yet. So let's just do. Let's just do the back panel here. With, I guess, some ASMR. My hand's cramping. Ooh. No, no, no. There we go. There we go. And this has a direction. If you can see it there, there's a bit of keying going on here. The direction being, of course, relative to our Toolhead board. And by the way, this printer is actually a bit of a special case, because this printer has the Raspberry Pi, or in this case a CM68 module, and the MCU, which is this tiny little thing here. Go away. So this tiny little thing here is the MCU that's actually controlling the printer. You could write a minimal operating system like Marlin or RepRap firmware directly to something like this. I'm not sure if this specifically supports it, but this is basically your Raspberry Pi replacement with your bigger ARM chip running Linux, and then having the whole Wi-Fi shebang, everything you need. And that needs to now be mounted to this plate once we insert it. The reason why I put it out here is because obviously we need to look at how we insert it, and we need to make sure that we insert it the right way. So when we put our back plate in here, there we go. The holes in the board need to line up with the mounting holes, which they may not be. Interesting. Why the hell not? Because it needs to go in the other way around with the two closer holes up top, because those go there. This is how that's supposed to work. I think we need to look at the instructions for that from Fysetc, because they may have something to say about this, on how this is supposed to be wired and how this is supposed to be connected. Oh, yeah, that's actually not what I was looking for. I actually want to see your video on it. This, by the way, being something that annoys me very much, that they don't have written instructions. We installed our plate. You can see the holes on the bottom. Oh, wait, you probably want to see the browser here. And I'm kind of, the reason why I'm pulling it up is because I am curious as to how they actually mount this plate. Because it needs to sit all the way at the back here. Or we need to add standoffs, and I want to see where those standoffs are coming from, what those look like. Ooh, and that's going to be a pain in the ass.
Put the preloaded nuts under the corresponding screw holes.
That is going to be a pain in the ass. Well, I guess we can make it work.
Lock with M3X6BHCS.
And we're supposed to use M3S6.
Find the corresponding printed parts, and then install the motherboard.
And I'm making a bit of a mess here. M310s, M36.
Tighten it with M2X10 self-tapping screws.
Because that one moved, obviously. Because it had to. Oh, that is going to be so much fun. Oh no, that is so frustrating. That freaking screw moved again. That freaking nut. Maybe we can coerce it back in a second. Just want to get the others in. And they both moved. The hell?
Snap the two-part prints together.
I got you now, sucker. And the last one.
Take out Raspberry Pi 4 and Cheetah v3.0. Insert Microsoft card into Raspberry Pi 4.
And I think we got all the screws. Nice. I kinda had the fear that this would be a major pain in the ass. It was just a minor one.
To lock the two motherboards on the corresponding printed parts.
The downside here is that we still have 2 unused screws in here. That sucks. But first we need to mount our motherboard now. And I have a feeling that we have a problem here as well. Because, well, we could actually just VHB these on. So yeah, or we're just gonna continue here. And this is the funny part, by the way. I don't think I printed the DIN cleats. Or the problematic part, rather. So what we can do here is just ask the Trident if it wants to oblige us with printing some DIN cleats. And if I see this correctly, let me check. We have 1, 2, 3 mounts. 1, 2, 3 of these. And we, yeah, need 3 cleats. Let's see what we can do here. Printer's already up. That's nice to see. And I think we currently have yellow loaded, so we're just going to print it in that. I would print it in black since it's electronics. But I don't think we need it. Yeah, you I want to print. And I want to print, whoops, I want to print 2 more of you. And I see that the studio did not pick up the slicer, so let's help it out somewhat. There we go. Let's slice that real quick. That's a 16-minute print, so what the hell? Just go. It probably will take somewhat around 40 because the printer still isn't heated up. But I guess that's fine. We can find something else to do. Like, for example, getting started on screwing these in. And we're supposed to, like, yeah, I guess we're good. Maybe play with Enek somewhat. Need a screwdriver here. Need to have a bit of an eye on the printer, see that it's actually starting. Yeah, that looks good. So let's continue here. And it barely got there. This kind of stuff, like wow stick, is don't get one. They suck hard. It really doesn't have the power to really screw into this, much less the other part as well. So I'm screwing into this first just to get the screw in. And then I'm going to back it off and screw into the other part. That way I also have less screws flying around here. And now it's empty. Piece of shit, I tell you. Piece of shit. Cannot recommend. But at least it held the bit securely, so I didn't have to look for it. I'll have to recharge it at some point. There we go. First one, second one. 2 more. I need to consult our video at Fysetc again, see how they want to really do this.
Raspberry Pi 4 is on the left, Cheetah v3.0 is on the right.
The funny thing, by the way, being that we do not have a Raspberry Pi and a Cheetah, but we have this single integrated module. So where is the assembly video for that?
Next, install the
I guess there is none. So we're gonna figure it out. We are going to just, well, actually there's another component we can use for a guide at least. It's this one. And this at least tells us where Fysetc expects the Cheetah port to the port for the catalyst board to come up. And we can have a look at that because it's supposed to be here. And that can also give us an indication of how high our board needs to sit to make this happen, which I can tell you right now, the print we're just starting is not going to do that. The reason why it's not going to do that is because the whole assembly would be way too high off the ground. But it is probably not high enough off the ground. Yeah, and it can't be the other way around. It can't be the other way around because then this little notch here will not fit. Oof. So we're gonna let our printer continue for the moment, but we are going to check the GitHub. And there we go. Check the STLs. Interesting. So, assuming that we have our board mounted here, and assuming that we have I'm gonna just back out the screws again here real quick. Because they might be in the way. Assuming we have that mounted there. We're going to take this for the other end. Something like this. Yeah, this doesn't even fit. How the hell do you imagine that going? These are the catalyst mods, if I remember correctly. Huh. Those jokers at Fysetc. Let's look at it. Catalyst mount 1, 2, 3. And by the way, the reason why I'm not canceling that print right now, by the way, these are exactly the ones we printed, is because we may still need them. One, two, three. Yeah. That is exactly what we printed. Probably this one. Oh, and this is a 3x. And we need 2 and 3. Oh, I get it. I get it. All right, all right, all right. We need to cancel our print now. We're just gonna blatantly e-stop that. Then restart the firmware. And restart the printer. Because the way they want us to do this is we have these. And these do screw into something. But the something is this. And that's going to get us our height. So what we need to do is we need to print us another one. So let's just remove these. No, not rotate, remove. Thank you. And let you see that. Let's see what I'm doing here. Need to find the Fysect kit. There we go. Reading helps. Reading helps. So where's our add folder? So we need us another one of these, and we need 2 of these. These are not multi-parts. Deselect those. Multiply this by 1. Slice this, 19-minute print. Okay. Print. The reason why I didn't cancel this print before is because obviously we would need to have it heat up anyways and heat soak anyways. And this way it was already heat soaking, so could just do its thing. This means it will now do these faster. Of course they're gonna come out yellow. But I don't mind. It's in the compartment anyways. In the electronics compartment. And then we're already prepping this one. We obviously can't prep the others because we need to screw into those from the top. But we're just gonna move on to mounting the PSU. Go the hell in there. Yeah, let me think. Well, what else can we talk about? Robert, any suggestions, any questions? Anything you want to talk about? Or are you just hanging out, watching me struggle here? All right, so now that we understand that and understand that we can move on, we can have a look at the manual. And by the way, I really like how they did, like the Voron team designed this here with clips to clip on the main board and the Pi. Kind of sad to see that not being the case with the catalyst. The catalyst just gets VHB taped on there and that's it. So removing it's going to be a bit of a pain. But we're moving on to a different board anyways. So this just being the stock build that we need to do. So I don't think we care too much. Okay, anyways, next thing to do is to install the power supply. Now things get a bit dicey because now we're talking mains. Mains power, mains wiring. And obviously the first thing we need to look at, ooh, printer goes blur. The first thing we need to look at is the switch in there, because that determines whether we are on 110 or 220, or in this case it actually says 250 if I see this correctly. No, it's 230. So I guess we're good. I guess we are good. That done. We're supposed to VHB tape that down. I'm not going to do that yet because I want to do a bit of the cabling actually outside the printer just for convenience before I move that in. Or well, actually, let's follow the manual. They may have a point here. What kind of sucks is that we don't have the top head built yet, so we can't actually turn it on its head very easily. I'm kind of, well, no, we're not going to build the top head, but we are going to VHB that down now. Let's just do it as the manual asks. Whenever we don't, funny things happen. Sometimes good funny, sometimes bad funny, sometimes just funny. There we go. Let's just go here. And what we actually can do is can see if our life hacks, those blocks are good for more than just squaring your printer. Ooh, and that trident just does it. That trident just does what it's supposed to do. It's like... That printer is so good. That printer is so simple. If you are in the market for a 3D printer and you want to build something that runs well as well as you build it at least, something that's reliable, something that's moddable, Trident. Although, to be perfectly honest, I think the Trident 300, I said this many times I think on the stream already, you don't need a 300. Build the printer you need, not the printer you want. And to find out what you need, look at, like, pre-slice a couple of things you want to build. Just grab yourself Orca Slicer, pre-slice a couple of things you want to print or build. See how they fit. See how they fit a 25 or even 18 centimeter square bed. And if they do not print a bigger size, because you can always glue things, you can always screw things together. The Fysetc inserts are a breeze and they look freaking amazing. They actually make a, like, if you ask me, 3D printed parts look way more legit if they have Fysetc inserts in them. It's just the way it is, or the way I feel. And while I am struggling with the VHB tape, you can actually watch the printer. Make sure it does what it's supposed to do. And by the way, still haven't fixed that USB connection, so 5 frames a second it is. Here we go. That's the first one off. This is the second one off. And now I would want you to see what I'm doing here. Guess I need to move the printer there. So, gonna take this, and if I remember the manual correctly, it said put it flush with the extrusions. So we're gonna do just that. I'm gonna put the power supply flush with the extrusions. Push that on there. I should have wiped down the surface, but I don't think I had a lot of fat on there. So fail on my part, don't do it the same way I did. There we go. That's on there. Continuing. This is also an interesting part. This is supposed to be the fan mount, but to be frank, I don't understand how Fysetc wants to have that built. Because I'm gonna switch here. We have two heat sets in the top and this magical square here that doesn't exactly look like what we see here on the in the manual, so we'll need to check the Fysect videos again. There we go.
Fine. Next, install the hot bed heating.
Let's see
Install
here.
the middle partition.
Yeah, we already did that.
Start installing the panel. Install the bottom plate first.
Nope.
Next, install the middle partition.
Let's assume we did that. And that, weirdly enough, is not what we have here.
Fix with M3X12 BHCS.
I can't for the life of me tell how this is going to go. It does not fit the extrusions. It says fan mount, and it is actually a fan mount because it fits the only Fysect fan that we're actually going to use from this whole kit pretty well. So if we look here, we can actually fit this. The question is, how do we want this part? I mean, we could just VHB it.
Lock fan 2 with M3X16 BHCS.
Maybe we can find a catalyst install. I think that's actually it. I think they want us to really VHB that to the back. They are crazy. Or to the bottom. I don't know. I'm gonna check this. We don't need to do this right now. I'd rather get the remaining wiring done. So we only have a little bit left next time. But this is very sketchy. This is very, very sketchy. I'll need to research on that. I'll need to research on that. Sure. But what we definitely can do, and what we definitely will do, is move on to the wiring, to wiring up the rest here. Obviously this we can't do. I don't mind. I'll figure out how that's supposed to go together. I can totally see that fan going in, but let's wire up our outlet here. And by the way, funnily enough, I know people think these wires and their colors mean anything, and to some extent they do. To some extent they actually do, but all in all, like at the end of the day, the only thing that matters in these is neutral and non-neutral. Because if you've ever seen a European or American plug, like this Schuko plug, European obviously, it has fixed connection. It doesn't have any decision making whether you plug it in this way or the other way. Right? The only thing that will always be the same will be the earth connection. But your neutral could become your ground, and your ground could become your neutral. So you can't actually rely on any of these being neutral or ground. It'd be nice if you did this correctly. It actually helps if you do this correctly, and it especially helps if you try to get your build certified in any way, like run it by an electrician. But if you're building electronics, these are reversible. The only countries where they're not reversible, as far as I know, funny aside here, is Australia and I think Israel, because both have the connectors at an angle, so you cannot actually reverse plug those in. Now, I don't like these connectors. I really don't like these connectors. These need to go. The reason is that even if you use these for your mains wiring and you screw them down on a riveted surface, even then you still have the problem that if your bolt cracks or heats up, like these come off way easier than if you have an actual proper ring terminal. So what we're gonna do here for wiring safety, and I'm pretty sure my electrician will actually ask me if I did this, we're gonna not use them, and we're not gonna not use them on the 24 volt side as well. We're just gonna snip those off, and then we need to strip them. And once they're stripped, about 5 millimeters of strip, we are going to use M4, I think it must be. Yeah, I think M4 ring terminals to screw those in place. By the way, one thing I want to make sure people understand why I love CAN, and since I just threw these around. Do you know what this is? This is a CANbus hub. This is how you can connect multiple tool heads or a tool head and your ERCF or anything else to CAN. You have power and ground for 4 devices, and you have CAN high, CAN low for 4 devices. This is all you need to branch out your connection. You need to have 2 devices that terminate your CAN wiring, but in general, CAN defines an inline device. So what people usually call daisy chaining is actually not daisy chaining at all. It's called a bus topology, and the bus topology says every single device is in a line on a bus. So let's actually get out the explainator mode here, because I have had that prepared for quite some time. Let's see if that actually works. And let's move to the top cam here with the zoom. So I asked for this, not you, but still, if you like this, then let me know. Let me know in the comments. Let me know if you appreciate something like this. But the main thing is, let's use blue and red, because I think yellow and green will not work as well. A bus topology means that I have in this case, 2-wire connection, and I have one device here, here, and here, right? And then at the same time, and I'm painting on myself, here, here, and here. Let's say that this is our CAN low and CAN high, and this is our CAN connection, right? And there's no daisy chaining going on. You're just extending the circuit if you have a bus topology. Now CAN mandates that you have a resistor at the end. So this in this case, that's 120 ohm, and you have your devices, and you're good. And anytime you want to connect something else, you just hook it up to the wires. Now CAN also specifies that this part, this side connection, can be up to 2 meters. So you can easily use your Wagos to just connect all of your CAN devices to the single bus. No problems whatsoever. Apart from me throwing things around. It just works. That's why CAN is such a nice bus system. Compare that to USB. USB, you have your computer, right, or your device, and that contains 1 to n controllers, because USB being a star configuration, let's assume you have 1 controller in there. Now you want to connect 2 devices. You need to have a hub that can now split your connection into 2 devices. If you want to connect something else, you need to have another hub, or you need a bigger hub here. That's also a possibility, right? Now imagine you're on your Toolhead already. Let's assume this being your main board, and let's say this is your SB2240 Toolhead board, right? You also have an ERCF using the Mellow Fly board. That's your CANbus. Now on the Toolhead board, you now want to connect another device, like a display. If your Toolhead board uses USB, let's make this the same example, right? So you have your Raspberry Pi. You have your SB2240, right? you have your ERCF, and you have your mainboard. I don't know, your Leviathan or your Manta, MP5, MPA, or whatever have you. And you now want to connect something else to your Toolhead board. You have two options. Either you run a completely separate connection to your Toolhead as well, which you obviously want to avoid because that additional connection is additional weight, it is additional point of failure. You don't want that additional connection. Or because you're now using USB, you either need to now run a CAN connection from here, right? So either CAN connection from here, or you need to have another USB controller in your SP2240 or whatever else Toolhead board you're using to be able to extend that. Like this is significantly easier if you want to extend anywhere. Now, the thing I ultimately want to see is connect and control on many levels using USB-C power delivery or CANbus. And with CANbus, you could actually have a dedicated controller that sits very close to your bed, for example, to your heated bed, and just controls the bed heater. You just run your CANbus. You only have a CAN connector on the close to your Pi, and you have all the other connectors connected to your CANbus very close to what they're controlling. Then cascading using USB makes it way harder than this, right? Here you just go, oh, I need something else on my 2240, so I take the same electrical connection that's probably exposed on your SP2240 or whatever else Toolhead board you're using. You add the other device, bam. Display in there. And to be honest, I do realize that CAN has a few downsides. I'm going to put this away now. CAN has a few downsides. Like you cannot easily enumerate devices, or not as easily as running LSPCI on your LS USB in this case on your Raspberry Pi to see what's connected. But once you understand how to configure it, once you understand how it works and what not to do, it's freaking easy. The main thing you need to understand is why there is a bootloader, because that actually enables it to work just as well as, and this is why I wanted to move these aside. It allows to work just as well as a USB device, with you being able to flash updates to it, reboot it, like reflash your whole system. And there's really, once you have it configured, there's nothing scary about it. It's just a matter of understanding. It's just a matter of understanding. And this may have been more difficult in the past, but I think a couple of problems also arise from people not understanding it. People just don't understand it. Like I see people configure their CAN devices for 500 megahertz connection speed. As far as I know, 500 megahertz is the minimum connection speed for CANbus. Minimum meaning that if you go below it, there is another standard that is low speed CAN. That is set at 125 megahertz. And if your controller cannot reasonably hold the 500 megahertz connection, then I think, and somebody correct me there, I think that your CAN controller, at least your built-in CAN controller in your MCU, will actually drop you down to that low-speed CAN connection, which your controller probably didn't intend. And that may screw up your connection and your connection reliability to a large extent. So the very first thing I always do, and this is, by the way, something I noticed even in the CAN boot, or nowadays Catapult defaults, I always use 750 or kilobit per second, or even 1 megabit per second connection speeds. This might be the wrong way around. No, actually, that's fine. For my CAN connection, so it doesn't accidentally drop into that low mode. Not because of performance, but because it's just safer to run it faster in this case. So if you want to really be on the safe side, although I don't see why you would ever have a problem between 750 and 750K and 1 megabit. If you really want to be on the safe side, drop it to 750. You don't need to, but do it. Faster is always good. Slower is shit. And that concludes that bit of the wiring. Now that is safe. Let's do the other one. And by the way, I need to check the catalyst board here real quick. Yeah, it also has the tremulous, so we're gonna do another two. Just need to find the cable. This is a who did this mess on the desk? Who's responsible for this? This cannot be. Who? Someone needs to take responsibility here. And yeah, these I want gone as well. Out of principle, not so much because they need to, but out of principle. Oh, and by the way, these connectors here, see these colors? They do not correspond. If you look at how I crimp these, there we go. These do not actually correspond to the colors of the connector or the cable. They tell you what kind of size they are meant for in terms of the cable size. With the red ones being for smaller cables, I think till AWG 16, and then you have the blue ones to 12 and the yellow ones for the really freaking huge cables. So it actually doesn't matter that these are not correctly colored. The electrician will look at the wire gauge and will look at the screw size here, and if those fit, you're good. I think. We'll see. And again, I am not actually recommending you do anything like I do it. This is fully up to you. You're responsible for doing your wiring, not me. I have barely any influence on how you do your wiring. You need to do this properly and as per code in the US or as per law in many other regions. You need to get this certified by an electrician. Otherwise, at the very least, you run the risk of insurance not covering any damages if you had like if you, for example, burn down your house. Even if it wasn't the printer, doesn't matter. There was a printer, there may have been a chance. So your insurance is gonna try to duck you, gonna try to get out of this. Freaking bastards. So get it certified. Just do the right thing. Do the proper thing. It's better to have somebody else look at this stuff anyways. Like, it's safety, it's peace of mind. So just adhere to code as much as you can. Yeah, these are solid. By the way, don't ever solder these before you put them into the ring terminals. Because solder is very, very soft. And may deform under heat, so yeah, probably not a good idea. So, next one. And by the way, I can actually zoom you out a bit again, so you see a bit more. Yeah, and please let me know what you think about this this topic and anything else we discussed here. Put it in the comments. If you see this, post the fact of me streaming it. I will not do individual clips anymore. If you especially if you see these on Twitter. And by the way, look at this. Look at this. These are nice. I noticed that when I do clips, the behavior of or the analytics show a very spiky user behavior. I don't like that much. I don't like you just watching 5 seconds of the intro to a topic or like the highlight of a topic. I think I'll just post timestamps because I noticed that you can't easily continue watching those clips once you're done with the part that got actually clipped. And that sucks. That really sucks. So we got this cable done, we got this cable done. We need to get our bed cable's done. Where are my snips? There are my snips. And there's one more cable we need to get done that I have no freaking idea of how. That's the earthing cable, because the fact is we must earth this frame. I have an idea of how, but we'll see how that works out. The fact is we must earth this frame. I'll actually do that right now. I'll actually get that set up right now. Because it's just a requirement. I know that others may not treat it as such, but if you have an electronics device that has any form of a case, and that case is in any way potentially running energy, it must be earth connected. Just the way it is. It's a safety thing. It's a safety thing. Wait, can I actually... I may actually be able to get to that in another way. Yes. Nice. Somebody had some good ideas here. There we go. And the way we're going to do this is we're going to preload another nut here. Yeah, because like whenever you have a potentially conductive casing, no matter what kind of casing that is, no matter what it is for, that casing could potentially in an accident be connected to one of your live wires. And if it is, it becomes a danger. If it is properly grounded, no matter the application, if it is properly grounded, it will immediately short out, trip your breaker, you're safe. If it's not grounded, then you touch it, you become the grounding connection. It will still tip the breaker, but again, then we get back into this more grim topic of those 100 to 200 millivolts, milliamperes, being able to cause serious harm to yourself, right? And you hoping that you get more, because then you just, I guess your heart immediately stops and you have a higher chance of surviving that. There you go. But we obviously want to avoid this, and because we want to avoid this, earth connections. And I kind of got sick and tired of just staring this, so I just clipped it in. Interestingly enough, though, that may become a bit of an issue. Oh, god damn it, Fysetc. Did it have to be this short? Did it really have to be this short? Well, I guess we're gonna find out how high bond this very high bond tape is. That frickin' sucks. Should have checked this beforehand. I should have checked this beforehand. Might be a sign from the universe to leave it at that. I really don't want to though. But I don't want to wrench on it either. And we can't take that plate out of there. So we kind of have to wrench on it. Let me write down that. That desk to get at the fancy spatula. I mean, the printers aren't actually really good. They don't do much. I think from a printing perspective, your Snapmaker is kind of shit compared to my Voron. At least the A250T that I have. But they got some freaking cool tools in that kit. Now the question is, how do you remove this? This, by the way, being something that is clearly in the manual. Yeah, it's clearly in the manual in the other way around, which means that the wires would have been long enough. I am an idiot. Just to show you this. Damn it. Guess I need to get this out. I guess I need to get this out. It helps to read the manual. Let me see here. Maybe the internet knows how to remove VHB tape. Let's see here. Okay, so it looks like citrus-based cleaner. And MEK. I have citrus-based cleaner. No, 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 no. What we're actually going to do. Let's try this. So we're going to try to cut it. And again, I have no experience with this. Just trying my luck here. So don't do what I do. If you know how to do this better, let me know. I am just trying to make this work the best I know how. And I kind of figure that if I can cut it in two, because it is a somewhat thicker film, then I can remove either side by just peeling. And if I get enough of it cut. That may be enough to just lever it out. But obviously we also need to be somewhat careful here, because we don't want to damage our bottom plate too much. I'm going to turn this sideways. Not so much visibility for you, but a bit more stable for me. I wish somebody was here. You could have told me. Well, Robert may still be here. Not sure. But this is the stuff that happens in these streams that an audience could really help me with. Especially an audience that reads the manual better than I am. Because obviously, I need to go back to school. Haha. Pure insanity. Pure insanity. There you go. This is how not to remove something that you stuck down with VHB tape. Make a note, kids. Do as I say, not as I do. And we can see some remains here. This actually came off pretty well, considering. Damn. Or, as the cool kids say, shit. Well, cool may not be the right term for those kids. But yeah, there we go. We got it off cleanly. So I guess cutting is an option. Now we need to stick it back down. Although, to be quite fair, I would have loved some DIN rails. Especially because I need options to redo things. This also, by the way, being a bit of a pain, considering that so many things on this printer get VHB'd instead of properly mounted. And we want to at some point move this to a proper Pi and an Octopus Pro to potentially have some fun here. I am dreading the time that I need to do this. I am dreading the day. But hey, at least it's content, and there are a couple people on Twitter who are gonna go nuts over this. Nuts in terms of they will probably watch this video, think what an idiot, and then move on with their life. But that's more than they usually do, so they might even lose a few pounds. Okay, that was kind of mean. What I will definitely do is not use as much VHB tape, because the more you use, the more you have to take off if you did it wrong. Scissors. And by the way, who the hell made this mess? I hope Steve at some point watches this. It's gonna drive him nuts. His OCD. Well, I can be OCD as well in some cases, but in others. In others, I don't care as much. And by the way, I still wish these were a bit longer. Does it actually? No, it barely doesn't. Damn. Oh, and by the way, the thing we talked earlier about with the whole CAN thing. Just because you can do things with CAN doesn't mean you need to. So I do see an advantage with people having an easier time configuring their printers by just being able to use like your LSUSB and always have an easy way to check if it's connected, have it essentially work like a second MCU. Also, I think Clipper doesn't give a shit of whether that is additional MCU is USB or CAN, to be honest. So yeah, I do see value in that. I just wish the hardware side was easier. Like I feel like the software side, sure, there's a bunch of things, but and I can see all those electronics guys going, whoa, this software shit, it's so hard, we need that easier. Kind of figure that there's more like electronics people and manufacturing people building Vorons than software developers, but for me as a software developer, sure, I haven't been 3D printing all that long. It's not even been 2 years, so yeah, I get it. I might have missed some dark times, but to be honest, that hardware side, sure, everybody has different ideas of how that should be done, but in the end, I think that hardware side for people who want to build but don't necessarily have the, for example, electrical skills, that side really needs to get easier, because while the software side has some pitfalls, there's not too much going on there that you need a degree for. But being able to just supply a power supply that outputs USB-C PD, that's certified, that you don't need to dig around with, that has a that you can build printed parts around, that would be so much better. That would be so much better. And by the way, we still need to terminate these. I am getting sidetracked here. But at least now the wires fit. At least now the wires fit. Yeah, anyways, I think the whole certification and safety issue with mains wiring, that should be addressed. That's the part you want to address. You don't want people that are not electrically inclined, and to be honest, that's most of the people. Like you and I am freaking scared of mains, especially since what we talked about earlier, basically. Yeah, but that to me is the biggest barrier of entry, or at least it should be. And if it's not, it's the biggest barrier to people being safe while they do this. And the I think that should be taken more seriously. I wish LDO would go after that, but I guess it's not as popular as well, that might be a bit unfair to say, but it is not as popular as building a freaking good mainboard. And they do that, and if they're really nice to me, I may even move the fuck. Oh, I may even move the the Trident to use it. Because while there are still things I would like to see, it is again a freaking good mainboard. One innovation I wish LDO had included, that is a personal pet peeve of mine that I am going to look into with the MP5, is shutdown and safe shutdown, safe power down. Because while it rarely happens that if you just turn off your Pi, your SD card corrupts, and while there are additional things you can do about that, like for example potentially running only in a RAM disk, and that might be something we can look at in the future, and having logs written to a RAM disk and not actually running off the disk at all, because I kind of figured that who the hell needs the actual disk? You only want to use the disk if you actually want to modify your printer installation, but otherwise you just push a file, print, push a file, print, push a file, print, and I for one would rather see my files reset or like gone when I power down my printer if I don't have a specific need to update something, which I usually don't. Yeah, we can, by the way, grab our parts from the Trident now, since that should be cold and the filter should have done its thing. Actually, still pretty warm. Ooh, look at that. And I think I finally got a good configuration with that elephant's foot gone. Almost gone. Almost. These look freaking nice. Anyways. There's still, I think, a way to make this safer, to make this less frustrating. And with frustrating, I mean that, sure, 99% of the time, you shut down your printer by just flipping the switch. You flip the switch, it's off. Next time it boots up, it's there. The reason why that's the case, why that still works, is because you likely haven't written data for some time. Your disk got synced, and then on boot up, the operating sees that you didn't shut down properly, it runs a quick recovery. Everything's fine, everything's there. But that process can fail. That can fail significantly. And if you ever run into this problem where your disk is not synced, you're screwed. So while I don't think the system needs to wholly shut down properly, at least running this sync when power disconnects would be freaking great. So how do you do this when power disconnects? And that's where a part by Victorytech comes into play that I want to try out, that has a bunch of capacitors. Now, if we can just connect the Pi to that, nothing else, just the Pi, and maybe the main board to, we could even get some brownout protection in there as well, but the main goal would be that I can flick the switch. That board still powers my Pi, so, and signals it to at least run the frickin' sync. Just run the sync, nothing else. That would already make me way less skittish when flicking that switch. And that would be a good thing. Because then I could be sure that my printer turns on properly without needing to do complicated checks and potentially screw up my file system the next time it boots. Wouldn't that be nice? Wouldn't that be nice? Yeah, and to get back to the Leviathan, LTO already went the extra mile to provide explicit integration for, well, not a CM4, which I would have liked to see, but for Raspberry Pis. So you can actually run a stock Raspberry Pi instead of some custom job like the Catalyst. It would have been freaking cool if they had a PSU included in that, just a big cap that is able to run your Raspberry Pi for just a tiny bit longer to signal it, hey, we're shutting down. Make sure you're safe. And just have that run that sync. Nothing else, just that sync. Doesn't need to be a big cap, just needs to be there. And that would help so much. In my peace of mind, at least. My peace of mind, at least. I know others probably don't care. Why would you? Why would you? So here's a funny question. If... Oh no, never mind. One is slightly longer. Okay. So let's grab our Catalyst board. Let's wire this bitch up. Baby, printer, you know what I mean. Anyways, let's quickly check what the screw size is supposed to be here for the Pi. Also self-tapping. These look kind of too big to be self-tapping. I would have almost thought these need to be heat set. Do I want these to be heat set? Might. I might want these to be heat set. Gives me a chance to show up the heat set insert press. Ho. The heat set insert press that I didn't invent because the world needed another one. Oh yeah, these are heat set. Nice. Yeah, another pet peeve of mine. You know how it is. I do like my thingamabob called Dremel workstation. Because it does not just have to be a drill press. And by the way, for the first time ever, as in ever, I will use the accepted method of heat pressing in your heat press inserts with a metal thingamajig. The thingamajig in this case being a ruler. Ooh, I smell plastic, which smells kind of weird. Not sure if I should be pleased about this, but it very likely isn't healthy. So let's get this over real quick. don't mind that. Well, actually, I do mind that because it is still a bit too far up. Let's see if we can do this better. We just need to heat it up. We don't want to press it further in. There's so much thermal energy in these brass inserts that it actually heated up the ruler. So I'm guessing probably shouldn't be using the ruler. Maybe we can use the scissors. Because these are substantially thicker and therefore have a higher thermal mass. They also cool down the part quicker. And I do need to remember to have the part properly seated somewhere, because otherwise it flexes away. Yeah, that's good. That's a good way of doing it. Don't run with scissors, use them to do heat sets instead. Whoa, and that went flying. Where did you go, little man? There you go. Whew. And I think once we have the wires in place, we're gonna call it. In the meantime, if you stumble up on the stream in the recommendations or any other way, oh, sorry. If you stumble up on the stream, I hope you watch it, and I hope you find something in here that is interesting. I hope you find something that inspires you. Maybe I can inspire you by not being able to do shit and probably being worse than you will ever be at all the things you need to do here. Except maybe the software. We're gonna rock the software. Probably, maybe. Potentially not. But maybe consider coming by next time. And bring your friends and family. And yeah. Maybe leave me a comment if I was in any way helpful. Maybe, yeah, share, like, subscribe. You know the things. You know the things. You know them better than me. I always forget to tell you this, but you're welcome here. You and your friends and your family and your I don't know. Do you have a cute sister? Oh, never mind. That's actually somewhat working. I kind of like that. By the way, the one thing I noticed people talking about recently how they like their heat-set insert press to behave. That this actually can't do, because of the way it is designed, is, ooh, this is too, whoa, whoa, that was too much heat. Yeah, it's like let it go and it snips, but it is so fast to just move it back in place. You can't have it snap, but don't. That's the only downside to these, but in general, I think they're awesome. Anyways, let's get back to our catalyst board, and something we haven't used at all. No, we're not going to use that. That looked horrible. That looked horrible. So, catalyst board. Come here. Come here. Let me mount you. Oh, 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 oh. I think M3x6 should do it, because we have about 1.5 inch, 1.5 millimeters thick. Whoa. My nuts are escaping. 1.5 millimeters thick. PCB, because that's how thick they usually are. They're not very thick, but yeah, they are thick. Thin. Anyways. Oh, by the way, imagine USB PD with real USB cables. I'm not sure. Have you ever seen something as cool as this? Give me a sec here. Let me focus. And that camera just nosedived. You know what that is? That is a USB cable. By the way, USB PD capable. Freaking huge. So at least 100 watts in power delivery. Can probably do 240, to be honest. I'm not sure about the specs though. And this is a USB-C cable. Imagine this with these nifty screws, and it already being secured coming out of your printhead. That is how I want to see it. This thing just screwed down to the printhead, screwed down to one of your 4 printheads even. That is sexy. And this can totally run your printhead, even at 100 watts. Well, potentially, I would go 130 at minimum, but we have a 260 standard. So, you know, that would be one sexy solution. Really, really. And yeah, I know, I'm complaining. And I'm gonna make so many, not shorts, but tweets about it. That LDO is gonna come to my streams annoyed as fuck, or they don't want to have anything to do with me in the first place. I don't know. Yeah. I need to reach you guys somehow. Again, I want to chat with you. I want you in the stream. I want to hear how you went on with a cross-threaded headset insert. Well, it's in there. No, how you got on with CAN, what the CAN install was like previously, how that all worked. Yeah, I'm interested. Let's have a conversation. Let's have a chat about it. And by the way, the two short ones go on the top. The long one is the one that goes slightly at an angle, slightly longer, so it goes on the bottom. you wanna see what an amazing look I just got. Someone's annoyed as shit. Hey Enek. Dinge tun? Dinge tun? Wollen wir Dinge tun? Kannst du Männchen? Kannst du Männchen? Kannst du Männchen? Nee, sitz. Männchen. Fine. There you go. Enek, again. Can actually, if I can get this untangled a bit here. There we go. Hey Enek, high five. Ja, hallo. Hallo. Fine, high five. Jawohl, sitz. The funny thing is, he needs to do hallo with the right paw. Well, with the left paw, but you're seeing it as his right. High five. High five. Fine, touch. Fine, Männchen. Männchen. Fine, tanzen. High five. Yeah, go. Up. Yeah, so best dog in the world. Can't put it any other way. Obviously, he needs to get a treat. That's a given. He just did something for me, so he definitely needs to get a treat. He would even get a treat if he had, but yeah, there he goes. Best dog in the whole wide world. We were kind of just walking along, minding our business today, again, as usual, and you would not believe the amount of attention we get. You just cannot believe the amount of attention we get on the street. Just because he's always doing things, right? He does his guide dog stuff. He does. I have this cord that we take for tug of war, and I just dropped that somewhere, and then I tell him 500 meters later, and then he needs to just go bring it back, and he does. But you get the looks. Like he's definitely having fun on the street, and people notice. All right, this we now need to VHB on, but the question would be, how does it relate to this? Then connecting it up should be pretty easy. There we go. Kind of interested to see how many others pick up the Explainator mode. By the way. Let me know any other topics you want explanators. Put it in the comments, as those YouTube people say. Because again, I'm here. I'm here anyways. And we're already almost at software. We have one freaking sheared off screw. Otherwise, we're pretty good. Gonna fix that screw as well. I'd be curious though how this mounts now. I'm kind of guessing that I can get this mounted with an M3 by 6 as well. Let's see if it works. Let's see if that works. Oh, that is sexy. Nice. Another M3 by 6 on the other side. Really can't complain about that. Oh, and by the way, I see that should have been further away. That as well. And this now gives us alignment points for our VHBing this on. Why, oh why? Why not? Why not do this properly? Well, we would be VHBing something on. The question would just be if it was DIN rails or these, so I guess the point is moot. Also, let me know what you think about today's music selection. I'm usually not the electro kind of guy. I do tend to listen to other things, to be honest. So, but I find it oddly refreshing to listen to electro sometimes. And while I don't have specific genres in mind, we can experiment. So if you want to send me down the completely wrong path and recommend me stuff that is really not fit for stream, because it is too aggressive or whatever else might be a reason for that not to fit a stream, here's your chance, put it in the comments. I want to hear it. And yes, I do know what dubstep is. Well, not that I'm any kind of a pro, but I have heard of dubstep. So the steps I kind of have figured out. This is gonna be so cool. In just about a minute, this is going to sit in here, and we can connect the cables. Well, make that 3 minutes, because frickin' VHB tape. Yeah, and let me know how you earth your printer. I'd be very curious, because I don't see another way around it. In my opinion, printers must be earthed, and I'd want to hear from you and how you approach the topic. And I can't get this frickin' film off the adhesive. Simply can't. And we're already streaming for, what's it? 7. Let's say 7:15. I don't know. Long enough, I guess. Yeah, if you're so inclined, if you want to get in touch with me and you hate the YouTube comments, join the Discord. Join the Discord, get in touch. There's enough space for everyone, they said when the Titanic sank. And then a bunch of people had to swim. Which they obviously couldn't, because you do not drink your whiskey with water. Well, actually, you do drink your whiskey with water if you're not used to whiskey. They just don't do it with ice. Let's make that 10 minutes, because I'm really having a hard time getting that VHB tape away from this foil on top. I'm pretty sure there must be some kind of trick on how you need to cut this, but every time I try to peel it off, it actually peels off the part and not off the tape. It peels the tape off the part, not the foil on top of the tape, off the tape. So that kind of sucks. I mean, you can see it here. This is a mess. This is a mess. Sorry. I should not have cut my nails today. I really shouldn't have. Tend to cut them too short. But they kind of annoyed me. Like just like the hair. Just like the hair. Like if it annoys me, I cut it and I do it myself and I do it like in 10 minutes. And then I have just about quarter of a year to half a year to have that grow back in. Kind of pragmatic with my hair that way. I am tempted to just screw this. We have another. There, it's straight again. Almost. All right. All right. And we want to push this through there. And then just line it up. Let it sit there. That's so perfect. That is so good that I must connect the frickin' toolhead. Which, by the way, probably shouldn't, but oh, what the hell? What the hell? Let's just go for broke. Let's just go for broke. There is, by the way, a new version of the Catalyst together with the Toolhead board coming. The interesting part is that they decided to go both CAN as well as USB. But they went CAN. And I love it. I really love it. They also, and this is something we will need to do 3 streams down the line, they also added connectors for the LEDs. At the moment, this toolhead doesn't have any LEDs, which kind of sucks, to be honest. I wish there were LEDs on this, but alas, they're not, and we'll need to live with that. So our prints are just not going to look as good as those with LEDs. By the way, I remembered something really important. Screw down the frickin' motors, it said. Once you have it all aligned, screw down the frickin' motors. But yeah, kind of cool to see that they went there. Would have loved to get a kit with the new board, but I guess it's still a couple weeks out. So Fysetc, if you like my complaining, if you think there is a future here for us, and if you don't mind that I will at some point throw out your stuff for Victory Tech, that's probably not a good pitch here, right there. just let me know. I would so love to get a look at your new board. That's the connector here. So we need another cable. By the way, this cable we're just not using with this switch because it would go here into this foot with a filament sensor. I didn't see the point of having a filament sensor here as well. I really don't need one. It might be cool to have one there if you're... Oh, you're shitting me. Oh, you're shitting me. It might be cool to have one there. But I can just as well make sure that the spool we're on does not run out. But you know what, Fysec? Maybe not, because like this is the second case. Like this, I'm not sure if the manual actually said to align the stepper this way or the other way, but that there is literally no reason why this cable can't be 5 centimeters longer, so I don't have to take out the whole frickin' Z-motor assembly just to turn the stupid stepper. That there literally is no reason, because this is the most pain in the ass part on the whole build. Really. I mean, sure, my mistake, right? It's like maybe I should read manuals more carefully. Maybe. But did it have to be like that? Like did this was it so important to save those additional 2 centimeters of stepper wiring? I mean, come on. That can't have been it. That you don't even see this part of the wiring. All right. This is going to be such a pain in the ass. I mean, those were in there so well. Kind of questioning why that was the case. That this is the why these wires needed to be so short. I mean, sure, wire management and stuff, but come on. You kind of expect to get extra points here just because your wires fit exactly without a single inch? I can wire manage just fine without my stepper cable being too short. It's like there's literally no gain in this. If you want to know anything that's frustrating on a build like this, is if you have to take apart pain in the ass parts like this, and sorry if you can't see anything here, and redo them because the freaking stepper cable is literally 2 centimeters too short. But this actually answers at least one question. Does Wet and Wild hold screws? And I can tell you, Wet and Wild screws are amazing. These were in there to stay. And now we're gonna have to do it all again. Let's see, at least 2 screws we lost. Oof. Yeah, these needed quite some force to crack. And I think it's still not completely hardened because I can still smell it. That is amazing. Anyways. Let's turn this like so. So. Put this back on. And let's screw it down again. With our makeshift Loctite. That actually doesn't eat ABS. There we go. Give us a bit more room to maneuver here. There we go. That is on there. Now for the other two. Ooh, and that smells. That smells. That smells like screws in there. Wet and wild screws. It is completely nuts. Speaking of nuts, I think they're still in place. Let's hope they're still in place, because if this is going to end up as well as the last time we did this, I'm gonna go nuts. Yeah, tell me what an idiot I am. Tell me what an idiot I am. That's what YouTube comments are for. If you want to have a conversation about what an idiot I am, join the Discord. But if you just want to tell me, just let me know that I should have taken my brain with me when attempting to build this thing. Put it in the comments. Let me know. Give it to me. That sounded better in my head. And that worked better than expected. And yes, I didn't apply Wet and Wild here again. Should have. But we have 2 secured, and these actually felt like they were still somewhat wet. So let's hope it's not a problem. Otherwise, we're going to do this again. Frickin' A. All right, and we still need to tighten these down properly. Because Wet and Wild or no. We want things to be tight. This cannot be a sausage in a corridor situation. Things need to be tight here. Oh no, wait, that was a different context. There we go. Now we're good. I hope I just did that on a whim. I didn't even check the manual, so. And I think we're good. I think we are just barely good. Should probably have gotten the LDO kit. They would have had the extra 2 centimeters of cable to have my back here. Just kidding, Fysect, just kidding. I mean, or not. I mean, I paid for this experience. But yeah, that's basically our steppers connected. We need to find out where these go. For that, we obviously need to check the wiring diagram again, which we'll find here. And that tells us that we already connected all of these things correctly. We don't have the display installed yet. We don't have limit switches because we're going sensorless, but tells us a couple of important things. First of which is the connectors here, like the rightmost connectors are the connectors for our bed power. So since we got our ring terminals on there now, you'll see in a second why they are nice. Can actually connect those up. Yeah, that's fine. By the way, look at maybe look at these connectors here. Give me a sec. There we go. And let's focus this. Maybe we can. No. Damn it. Yeah, it is what it is. We can fit, maybe do it this way. There we go. At least you can see something. Look at these. These are completely flat. So let's imagine that you tighten these down, and after a while they shake loose somewhat, right? Because here you shouldn't actually apply a thread locker to these, because thread locker is non-conductive, and non-conductive may hinder your connection, may then result in it warming up and or heating up, and a hot connection point may suffer other damage as well. So the connection may loosen after a time, and then your Fysect supplied connector may actually move out, like slip out here. That's why I like these ring terminals, because you screw those down, and unless that screw comes completely out, these are safe. And if you do your yearly or bi-yearly checks and your printer hasn't shaken itself apart, then these are probably still in there. They may not be all the way tight anymore, or they will be. I don't know, maybe. You'll have to see then. But the fact of the matter is, unless the world catches fire, or you do really weird things to your printer, these are likely not coming out. We are also going to connect this here. There we go. Probably need to do some cable management later. Might actually want to disconnect the stepper real quick on this side to just move these cables over. There we go. We also have a Z limit switch, a 3-pin. Oh no, that's the two switches. Like if you look here, you see those two switches? I would have liked it if they were labeled, because one of those is your Z limit switch and the other one is your filament sensor. And they don't tell you which is which means that in your config, you're potentially going to have a bit of a problem, because then you don't know which is which. But yeah, anyways, not that it matters much. We have it connected. We also need to connect these. Voltage on the inside, ground on the outside. and I really need to do something about that chat. I'm gonna move you over to the other view though. I'm not going to connect this to the power supply yet, because I would want to first make sure that the power supply itself is at least supplying 24 volts. We're going to do that in a second, I guess. Well, or at least once we have it connected. But we also still need to earth connect this printer. Well, I'm going to do the earth connection off screen, to be honest, because the way I do this may not be the way you need to do it. It'll probably be visible in the next stream, but essentially what I'm going to do is try to pierce the anodization by screwing in a screw so hard into here that it pierces it, then use serrated washers against the surface and screw against those and the already serrated. I'm probably also going to scratch up this area quite heavily and use the serrated washers together with the pierced anodization to really get in there, to really make sure I have a strong connection against this. Then run another wire that we actually can crimp right now to the earth lead. The main issue will be that I will need a way to Y-split this earth connection, and well, I guess that's going to be a bit of a pain. I'll just need to order that because I don't have one here at the moment. Well, actually, we could do Wagos. We could just do a Wago. Yeah, let's do a Wago. There we go. Wago. We go. Go away. Where you go? Gonna deal with that later. There we go. That means, of course, that to make this work properly, and I'm gonna use the... Damn it! It's escaping! It's escaping. To do this properly, we need to again turn the printer on the head. Maybe a bit like this. Some focus. And I would want that to sit somewhere there. And I'm just going to snip that here. Again. Strip this side. Good little strip here. Twist these together. Push that in. Other side, same thing. Pull that out. Twist these together. Push that in. Now, since my device essentially relies on this connection being proper, I am going to grab the multimeter. In this case, a Fluke 85 that I bought used. That has been with me for ages now. And that is basically my daily driver in multimeters. And I am going to check this lead. And we're good. Now I also need to grab some reasonably thick wire. I think this is 16 gauge. Might be 18. Not quite sure, but it is definitely heavy duty wire. It is PTFE wire, so it would be safe to run in drag chain as well. But I specifically got it for use in situations like this for mains wiring. Twist that. Push it in. That is in there. Now let's find out how far we need to go. About here-ish. Like just under the foot. Gonna snip that off. And yes, I'm routing that through the printer once. I would like a shorter connection, but I do not want to take off that IDC connector, and I do not want to take off my motors. So any connection is better than no connection. We're just gonna find ourselves another ring terminal. And by the way, this is still short enough, I guess. Ring terminal on there. Pearl on there. That's solid. And now that we have that sorted and we know how long our wires are going to be, we can pull the tape off the Wagos and just stick that on. I could have doubled up on the screw terminal as well, but I really don't like that. And I think, I don't know, Wago mounts are actually up to code here. So as long as I get the frickin' backing tape on this VHB, we have a solid earth connection. And this should be good. This should be good enough. I mean, look at this wire. Imagine, like this wire can handle a couple of amps, and it only needs to handle it until the breaker trips. So, should anything ever fail in this printer, and anything ever connect the printer housing to 230, which by the way can happen. This is not something that's just hypothetical. These rules come from somewhere. If this power supply fails in any way that God forbid connects your life to its output, yeah, it's gonna roast your controller board, and it's gonna smell. And the first thing you're gonna do is you're gonna grab the printer by what? Its panels? No. You're gonna grab your printer by its frickin' extrusions. If they're earthed, you're good, because then the potential, like voltage is a question of potentials, right? Imagine like what we talked about earlier, right? Your Pixies, your Pixie potential. How many angry Pixies do you have? And the more wings you take from your Pixies, the angrier they're gonna be. By the way, I need to test this. If you have 220 volts of angry Pixies, there we go. Kind of shaky hands now. If you have 220 volts of angry Pixies, that means that on one side you have 220 angry Pixies, and on the other side you have their wings. If you have 50 volt of angry Pixies, you have 50 Pixies. And obviously if 50 Pixies are mad at you, that's gonna hurt less in the face than 200. Just saying. But if those Pixies have a way to get their wings that does not involve your body and your sizable stature, you're fine. If those Pixies have to go through you to get their wings, you're gonna be shit out of luck. All right, so this is wired. earth is mostly wired. Let's do this. Let's do the tricky Mickey. Gonna move that there. We are going to Enek. You're in the way right now. We're going to need serrated washers. Question is, where did I put those? Should have thought of that beforehand. We're not going to need the printer anymore, so I'm just going to turn it off. Did I put those here? There we go. Have some of these, because these are amazing. Whenever you have something that is not supposed to come loose, like for example, I should have put some of these on the bed, under the bed, between the bed and the nuts. These are freaking huge. So what we're going to do is we're going to take 2 of these. We're going to take in and 3 by 4, I am guessing. And yes, that is something that is not included in the kit. Then, and this is, I think this is the way to do it, is you put 1 on top of your connection. Then you put your connector. We, by the way, may need to go by 6. Yeah, we need to go by 6. So those are actually included in the kit. Those are included in the kit. I'm just going to take one from here, since I already have the actual slotting box open, which, by the way, was way easier to find than these freaking plastic bags. So we're going to go serrated washer, ring, serrated washer, and then we are going to grab our screwdriver that has the wrong bit in it with the correct bit being missing. Of course, because how else could it be? There we go. And we're just gonna screw this in there. Gonna see how well it makes contact. If it already makes contact well enough, we're good. We could have actually gone with a way shorter cable, which is no problem at all, since this is a Wego mount, so we don't even need to take this apart anymore. But what we obviously want to do is we are relying on those serrated washers, well, that one serrated washer, to get through this anodization. And I'm actually going to shorten this here. I don't like this. This can be way shorter if it's just routed this way. We can take it down to there. Knips. And whoop. And now we just need to route it back to our Wago, put it in, close the frickin' thing, and test for continuity. We're testing the washer. Nothing. That likely is a result of this not being exposed wide enough, long enough. So take a good chunk off, like 6-7 millimeters, I guess. You don't want the wire to actually peek out the front, but you want a good chunk to be, damn it, you want a good chunk to be exposed. There we go, that's in there. Running around the stepper. I don't actually like that it tries to touch the stepper here, but I think I can form that away. And potential wire management as well will take care of this. So just to make sure you get a better look at it. Let's do the magic printer stand again. There we go. Earth lead connection there. Going to our Wago here. Let's see about continuity. That and that. That's beautiful. That and while I am having some difficulty getting through the anodization, you see if I peek it hard enough, I can actually get continuity to the rail now as well. There you go. That is how you do pretty solid earth connection, I guess. That's just on there. It's not going anywhere. Don't Loctite it. Again, Loctite is an insulator. And while I wish I had this wired up closer to the actual outlet or inlet, like for example here, that would have meant taking this off again. I wish there was a channel to actually route that here and put it here. If there was, I would have reconsidered. I would have probably put the nut there. Yeah, that's essentially it. Now that we have that safe, we can go and connect it. And by the way, that's the first thing I would always connect. Nothing else, just this. Because we want to connect this and then test if this housing, which needs to be earthed as well, and which, by the way, also touches our rail, but we can't rely on that connection because there's the anodization in between there. Yeah, it still needs to be earthed. And by the way, I do realize that these connectors are serrated. Oh no, they're actually not. Well, they do have a couple of serrations on here. So they would be harder to slip out of for the cable in any case. But I still like those to be ring terminals instead. I'm not quite sure whether that's actual code or whether that's a personal preference, but this is mains wiring. Mains wiring. Stuff that can kill you wiring. So I do not want to screw it up. And there you go. This obviously doesn't because that's a sticker here, but that housing is earth connected. And if anything happens to that housing, you can clearly see there is a low impedance path between it and the if anything happens to this and it exposes any voltage, there is a low impedance path even to your frame. Now let's wire up the neutral and live. Again, if you're not in Israel and you're not in Australia, then technically you cannot rely on your live being live and your neutral being neutral, because there is no like switching mechanism in your plugs that actually turns those around if you just plug in the power connector the other way, right? They are reversible. So since they are reversible, your live can become your neutral and your neutral can become your live. But ideally, just do as you're told. Go to your room. No, kidding you. Don't go to your room. Instead, watch me burn down the house. And we're gonna burn down the house by connecting this to some actual power. Now, the thing to do here, and I realized that just now, is ideally I don't want these to be exposed. I'm gonna work with it right now, but usually I would want to cover these and would want to test whether we have 24 volts on the other end. But yeah, I already screwed that in and I don't want to deal with it. I just don't want to deal with it. And I also pressed some many keys. So what we're going to do is we're going to grab our power cable. We are going to make sure that the printer is off by the O being pressed in. Then we're going to connect this side first, because I want to see if the printer goes up in flames immediately, so I can actually react. And I'm going to do this, and this is something you can't see. I'm going to do this using a, well, actually, I may be able to show you. Using a like multi-plug. I don't know, the word escapes me right now. Not a native speaker, so screw that. And I want to turn this off. Gonna plug this in, and I want to see immediately if the printer goes up in flames. I saw something, and that something probably was the earth connection. And I don't want to touch the printer just yet. So I turned it off again. Now I turn on the printer. And now we should have power. Let me maybe turn it off. And that is definitely on. Gonna turn that off again. And now we get into measuring. Let's measure the shit out of this thing to see if we actually have 24 watts before we turn it on, before we actually connect it to anything else. We are on volts DC. There is some tension in myself, but not too much. I am going to, just for safety, if you're ever doing anything with a 24 with a mains wire, you want to, like, these sometimes just check your multimeter. These should have something like this where you can add a shroud or turn a shroud. And if you ever like are dealing with connections like this, just get the shroud, and we're going to go live neutral ground, 2 plus 2 minus. So plus, minus, we're going to hold these on there, and we have a stable 24.24 volts. Isn't that cute? Just for you to see this. There you go. 24.24 volts. Pretty. So that seems to be stable. I turned it off, by the way. Just because I turned it off, the power supply does not immediately lose all its pixies. There's this thing called capacitance, where you can store a bunch of pixies on one end and a bunch of wings on the other end. And if you put a thick enough wall in between, those pixies just can't get to their wings. So they stay angry until they kind of lose interest, and then just slowly go away. Electricity, right? At some point, those pixies are just going to be annoyed and not angry anymore. There you go. So, before we do anything else on the wiring, we turn off the printer, and now it gets kind of critical, because now we also want to remove this cable, and for safety, since we now have a live connection inside that printer, we're going to tape off the plug and tape down the switch. This is actually part of proper isolation while you're working on devices. Well, actually, usually you have a log box there and stuff like that. This actually, I only know this because I am working for a company in the workplace safety field, and we do have trainings available for this stuff. So yeah, if anybody's interested, check out Pixera. But in general, close this off as best as you can. So you at least have to think about why you did that before you need to remove it. You have a live exposed connection in here now. Moving on. We now want to screw in our mainboard connection. And I guess you can't see shit because I made it so you can't see shit, but I want you to see shit. And by the way, I know that the 1, 2, 3 blocks are kind of scuffing up my extrusions, but to be honest, I really don't give a hoot. Shit, fuck, whatever. Printer needs to go burr. It doesn't matter if it looks good. Taking out these. And now we need to be careful of which direction we do these, because these are tricky. Usually you'd expect the plus to come first, then the minus in the order you read them. But if you look closely, it's actually the other way around. It is actually the other way around. So yeah, need to do this the other way around. Otherwise, bad things happen. All right, so we have our mainboard connected. We don't have an SD card in here yet. I need to figure out the operating system, what's on here. Need to take that apart a bit, see what's what. In general, no big deal. Oh yeah, one thing I do still want to do, since we're here, since we're there, is get the backs. Oh, actually, no, I don't want to get the back skirt installed yet. Let's see, what does the manual say? Where do we continue? We did the wiring, and by the way, pretty good job here by Fysetc, even though the cables could have been just a bit longer, so I didn't have to take out the X mount again. That would have made my day. And also, by the way, I think I need to print the cover for the LRS. I do have one. I will check if I can find that and potentially install that right now. But I think it is in dark gray, if I have it. Nah, can't find it. It's not there. So that's something I still need to print, is the cover for the LRS. I will turn this on right now because we're basically done with the wiring. So am I safe? Yes. Do I still have fingers in here? No. So I can actually take this off. And I'm not going to plug in the SD card, but I am going to look whether we see flames immediately, whether we can see anything here. Going to turn on the printer first, so I have my fingers off the printer when I turn on the power. And we have lights. We have a lot of lights. That is looking very promising. Nothing's burning, nothing's smelling. Cool. Turning that off again, because I don't want to have it running too long, because there are steppers that don't have heat sinks yet. That's something I will do till next week. I will also make sure I get the fan installed here, because that is still missing. I need to figure out how that needs to go. Otherwise, we got there. We got there. Pretty satisfied. Wiring is there, electronics are there. This printer, if you look at it, looks freaking amazing. We got our board on here. We got the cabling on the Toolhead done, although that may need some cleaning up. Yeah. Awesome. This looks like a printer. This looks like an actual in-your-face working printer. So next week, we still have a top hat, we still have some skirts, we still have a display to build. Actually, let me check here real quick, because if we can build the display right now, I'm up for that. Yeah, come on, let's go. Let's go. That sucker's on here. That sucker's on here. Let me disconnect this and put some tape back in place, because I do want this additional trigger. manager off. That way I can be sure it is off. And one fat strip. There we go. Don't turn this on, I may have my hands in it. And then we just put it on the magic stand again. Let's get this display sorted. I actually already have it in here. I mean, you saw it, I put it in there to somewhat protect it. So that already looks like this. There are a couple screws missing still. But the diffuser is in there. Everything's in there. Knob is on there. So we need some 4M10 self-tapping, M2x10 self-tapping. Can probably find those. I think they were on this side, right? And 3x6s. Some rail stops. Ooh, the chaos. Ooh, the chaos. Yeah, let's get this done. Let's get this done quickly and quietly and without making mistakes. Not sure if we can manage all at the same time, but we can certainly try. And I found them because I managed to put them all over. 1, 2, 3, and a fourth. And we need our 1 and a 2. Mounts. We are going to just so you see what we're doing. Gonna screw those in. By the way, I like the Voron screwdriver, but the way they did their logo, very much not appreciated, because that is just going anywhere but where it was supposed to be. And this may have something to do with me being a bit heavy-handed when wrenching down parts. But seriously, I would still have expected better, because this seems flimsy. This said via at some point in time, and I'm guessing you want to have that say via again on the stream here. Now let me quickly double check the construction here, because it doesn't seem like we can properly press in the button. So the reason for that is usually that the diffuser isn't seated properly, which then pushes up the button, which makes the whole assembly not sit properly. Push that in. Put that on, and then we're just gonna screw that right down. There we go. Well, no. That is actually wrong. That is the wrong side. But it's good to know that we can actually screw it down that well. Did I already put that somewhere here? Gonna go nuts here. I thought I had 2 of those. I thought I had 2 of those. Where is the freaking other one? Oh, there we go. That one was hiding pretty well. Put that in there. There's the other 2x10. Yeah, so yeah, and the reason why I want to put this in, because then I can also put the remaining skirts on. And then it's gonna look freaking amazing, like a little printer. Awesome. Awesome, that's exactly how we want it. And then we throw it down. And 3x6s, 2 and 3x6s. 30, 30. You know what? We have a printer now. We have ourselves a pretty freaking cool little printer. And it only took us more than 20 hours, or twice as long as Nero. Well, actually almost 25 hours, more than twice as long as Nero to get to this freaking point. Although the guy cheated. The guy cheated. Let's be honest here. Let's be honest here. The guy cheated. He already prepared things off stream, and we didn't. We expressly didn't. So yeah, Nero. Do it again. For real this time. For real, for sure. Let me know how slow I am by just completely destroying your old record. I know I'm not good at this. I know other people are way better at this, but maybe somebody can find some value in what I do here. And value does not necessarily mean anything but some good old entertainment. Not that I am an entertainer, but I may be entertaining with the shit I do. I don't know. You tell me. And while you ponder that one, I will equip our Voron signs and screw these in first because it will be a freaking pain in the ass to get to those later. That means M3x6 is there. And by the way, it will, oh no, actually it won't be a pain in the ass. Never mind. Never mind me. I just want the printer done. There we go. Now we just need to get those two in. Gonna preload these. And then I'm going to move the nuts into place in the hopes that this is not going to be as much of a pain as this frickin' Z-axis. And nope, I'm not going to Wet n Wild these. Because it's a good day if the skirt falls off. And as punishment by the universe, that nut went somewhere it wasn't supposed to be. That's divine punishment. Divine by who, you ask? I believe in the universe, my cool mistress. You're trying to kill us so hard. That we don't have any choice as to just oppose you. Ha! Hoo-yah! And that triggered Enek. Cable. Let's get it over with. Let's get the frickin' cable in there. That ain't it, that ain't it. That ain't it, then that. Interesting. Some cable. That is one weird cable. It basically has a USB male on both sides. That is one weird cable. And I think this is our Wi-Fi. So let's maybe plug that in as well. There we go. Only I knew where I put the display cable. I mean, it must be a bit of a longer flat cable, right? You can't easily hide those. Swallowing those would be painful. Oh, nice. We have two of the cable organizers. It's gonna be some good cable organization once it's done. Although we're not gonna get to that if we can't find this freaking cable. And by the way, I am kind of impressed because there is plenty of hardware left. There is plenty of hardware. So while the quality of the hardware was not always fully to my liking, I gotta tell you, they did not skimp on the quantity. And by the way, the quality, again, that may have been me wrenching on the freaking thing too hard. Although I do think that some quality stainless hardware would have held its own against my heavy hand. And even from a longevity perspective, I would have preferred stainless hardware. Not a requirement, but I would have preferred it. And I don't need it to be black. Actually, I like the look of silver in hardware. Might be alone in that, but I do like the look of silver hardware. That is so weird. That is so weird. Where did I put that one freaking cable? I remember playing with it last stream, but I cannot for the life of me remember where I put it. I mean, we could potentially just go and use the display from the salad fork, but nah. The display from the salad fork has a USB connection. I'm kind of guessing we need the IDC cable here. Because we can't probably attach the IDC cable to the salad fork. Yeah, I guess this is a very abrupt end to this stream. Abrupt, I was going to say. We still have a fan to fix, we still have that cable to find. It is still already looking like a freaking awesome printer. We have to do some more cable management below the printer. There's definitely some stuff left to do here. We need to secure the second end of the cable chain still, or the wiring loom there. Otherwise, really satisfied. Really got far. So next time it's only a couple of short hops and a jump to the to complete the wiring before we move on to software and having a look at that. In the meantime, I will try to figure out where the cable is, but also where and how I need to set this up so we can do this easily and neatly on the computer with us remoting into the not Raspberry Pi of this printer and have that talk to us. Yeah. Really happy. Look at it. Really look at it. Stare at it for a couple seconds. Isn't this a freaking nice printer? Doesn't that look extremely cute? That's it. There you go. That's it. Again, if you have topics you want me to talk about, if you are interested in journaling, grabbing a stream, seeing what we talk about, influence what we talk about, have your own insight, prevent me from doing stupid things like rotating the z-axis the wrong way, or the connector for the z-axis the wrong way, or skipping a pulley in the belt configuration. I would love to have you here. So just so you don't miss the next stream, go down, turn that red subscribe button gray, click the bell notification on the side of it, so you actually get notifications, because otherwise you may not. Share, like, put all my mistakes in the comments so I can prepare to fix them next stream. I'll see what I can do about this frickin' screw there. That is the only major issue we have on this printer right now. Everything else we got sorted pretty well. Yeah, I would love to see you in the next stream. I'm sure Enek would as well. In the meantime, enjoy, go watch some Doctor Who, so you actually understand the quotes at the beginning of the stream. Yeah, and thanks for playing.